Okay, good morning everybody. Molo, good morning. Good to see you all. Excellent turnout. I know we're starting just a little bit before 9 o'clock. Maybe we should have started at exactly 9 o'clock to give people a little bit more time. Okay, so let me explain a few things. So a little bit of housekeeping for the conference. Okay, first main thing is that this is session A, you've realized that already, and session B is just down the corridor on the left. It's the second door on the left. Okay, the next one is Investec. They've got a session going on, so go past that one and then it's the next door. So we've got labels on the door to say which session, which Icecet session we've got. And session C is on the right, going down the passage, and you see the label there. Okay, so let me get to a few points. Okay, so this conference has got 2 days. So this day is the in-person, and all of these sessions are going to be streamed. So, and you've been sent YouTube links, both YouTube links and Zoom links. So by all means, you can invite colleagues or postgraduate students that you might be supervising to watch your presentations if you are interested in doing it. So that's stream, live stream. And if there are questions on the online, we'll be monitoring that. But let's get on to the few points about the schedule. Okay, so the main point here is that so each presentation we need to try and keep that to 12 minutes and maximum 3 minutes for questions. Okay, so that 3 minutes is for questions and switching over to the next presenter. Okay, then I want to remind people about the posters. Okay, so lunch is from 2 p.m. and the posters, I know that's why maybe take a little bit more than half an hour, which is okay, maybe there's a bit of overlap with the posters and doing lunch. Okay, but please do try to attend the posters and ask questions that you might have on that. We've got half an hour, a little bit more than half an hour for the poster session. Now, I know we don't have all of your slides on the laptops yet, but please do try in the coffee breaks get to the session that you assigned to, and there will be assistants there to help you copy your. So if you've got, you could put your folder, the slides on a USB stick, and you can copy it over there. We've got USB sticks if you need to borrow one. Okay, there is a USB stick on your Icecet. There's a little card that you have, and you can disconnect the USB stick from it. Okay, there's a couple of gigabytes on there that you can copy things on. Okay, right, and then this last session is ending at 6:15. So I'm hoping we have good attendance throughout. Okay, so some statistics about the submissions. So we had rather impressive 711 papers that were submitted from 73 different countries. Okay, of these, there were 308 accepted, so 43% acceptance rates. So in the proceedings, we will have this information indicated as well, which one sometimes needs for reporting on conferences. Okay, we've only got 93 physical presentations this time round, and we've got more than double that of the online presentations. Okay, so online tomorrow, and there's I think it's 5 parallel sessions tomorrow that are online. Okay, some further notes about the proceedings. So all the papers that are accepted and presented, so please, only to present your papers, there must be at least one author participating in the presentation and able to answer questions on that. Then the chairs will be ticking off that they are present, accounted for, and we need to report that to the ICWE. Okay, so it's going to take a few months. Oh, this one was better. Okay, now, I hope you can hear me better. Okay, so it will take about 3 months for the proceedings to come out. So that will probably be around February that the proceedings will appear in ICWE Explore. Okay, so, right, so those are the main slides that I've gone through. On day 2, that's on Zoom. So on Zoom you can participate with posting questions, discussions, you can have chat going. But those are all run on Zoom and also will be streamed as well on YouTube. So if anybody wants to just connect on there without having to go through the whole Zoom login, that's available. Okay, just some points about the time limits over here. So maximum 12 minutes, please, for your presentation, and then 3 minutes for questions and switchovers. Now we've got some warning flags that will appear. Okay, we've got a 3 minutes flag in yellow, so we decided 3 minutes to make sure that we've got at least a bit of time to wrap up and still have a bit of time for questions. And then, yeah, unfortunately, we need to stop as well. Okay, so the chairs, please, if you could make sure that you keep things to time, and our venue assistants will also help with that. You can help with keeping the timing of things. Okay, yes, so I went through those main responsibilities, and the session chairs will have a list of the presenters that should be present, that they need to tick off on the list. Okay, for questions, please, just to be totally clear for everybody, sometimes I get asked this. Please keep your questions to the end of the presentation, so that we can keep you time. Okay, further questions you can ask at the registration desk. And yeah, what is the next Icecet, just in case you're wondering and need some sunny place to visit? That is in Sydney, Australia, next year. And it's going to be 25th to 27th of July, and the callable papers will be available soon. Okay, so staying in the southern hemisphere for now. Okay, so let's get started with some knowledge sharing and get going with the conference. I would like to hand over to Joyce Montgomery, who's going to do the keynote presentation today. And Joyce, you can, you've got yours.
My name is Joyce Montgomery, and I'm based at the Department of Electrical Engineering at the University of Cape Town. And I'm going to be talking about digital health in Africa, highlighting what some of the challenges are in achieving digital health ecosystems, and some of the research opportunities and what we've been doing or would like to do. So, a quick intro about me. I am, as I mentioned, in the Department of Electrical Engineering. I'm also the director of the UCT Telecom Broadband Center for Broadband Networks and Applications. I also co-founded another group, the UCT Center 5G Center, as well as a member of a couple of other groups such as the African Robotics Unit and the Telemedicine and Connected Care groups, all at the University of Cape Town. Outside of the university, I do some volunteering. For example, I co-convene the Icecet 5G Forum Working Group on Research and Development, and some IEEE activities within the South African section and within the IEEE Communication Society. So just to give a brief intro or putting everything into context, why do I focus on digital health and what digital health could do for Africa? Just a brief history of the research that I've been doing for the past couple of years in my PhD and beyond has been in the area of developing experimental test beds that students, researchers can validate different networking applications, algorithms, mechanisms, management and orchestration systems, so that we can validate things over real world or close to real world environments. The idea behind this is good, but it also makes sense to extend this further by making some of these technologies that are developed within these test-bed platforms be more useful and applicable to the general population. And we've identified healthcare as one such kind of application that could benefit from digital technologies, and that's why we're doing a lot of research in digital health. Healthcare in Africa is quite challenging. Africa bears a very disproportionate burden of disease and death due to various diseases like HIV/AIDS, malaria, tuberculosis. I have some stats here. For example, in sub-Saharan Africa, we have more than half of the world's population that's currently living HIV positive. If we're looking at malaria, we have 90% of the world's yearly malaria cases occurring in Africa, and mainly in children under the age of 5. So we see that there's a wide range of challenges that one needs to overcome to ensure that the citizens of Africa, the population of Africa, is able to access adequate health care. There are further disadvantages. For example, we have some unique diseases that are only occurring, for example, in some of the tropical areas of Africa, as well as the traditional non-communicable diseases that are burdening healthcare systems, things that are preventable, like heart disease, obesity, diabetes, etc. So we think digital health is a possible way to alleviate some of these healthcare burdens in Africa. And we're not the only ones. Many economies around the world have invested heavily in digital health. If you look at some of the Nordic countries, they have very sophisticated digital health ecosystems that is accessible for their entire populations. When we're talking about digital health, we're referring to the enhancement of healthcare delivery with the use of digital technologies, for example, the internet and connectivity, or enabling some sort of electronic systems like electronic healthcare recording systems. Also, simple applications that can be run over mobile phones or smart healthcare devices. All of this encompasses what we consider to be digital health. So obviously, digital health would rely on reliable, available internet access for such services to be functioning effectively and adequately for the population. And again, we see Africa largely lacks good infrastructure, especially outside of the urban centers. In the rural areas, there's close to very limited fixed line access in terms of broadband access. So these are some of the structural challenges that we're seeing when we're trying to implement digital health in Africa. As I mentioned, in the other industries, such as, let's say, in Sweden, in Norway, in the UK, in Australia, where they have really complex, vast, and far-reaching digital healthcare strategies and systems that are accessible to their populations. It's not simple to take those systems and just simply plug them into the African context, because we have different challenges. We're facing different diseases. We're facing challenges that they're not facing, for example, limited access to stable electricity. You may have noticed in Cape Town that we have something called load shedding, which means that it's not always lights on. And things like that are going to affect the ability of these systems to and how they're useful. And another challenge, as I mentioned, is the degraded internet connectivity outside of urban areas, and also the high cost of reliable internet access. The reason that this is occurring is because most service providers of the internet are focusing on urban areas because that's where they are going to be reaping their profits, and they don't invest in rural, in underserved communities to offer internet services. But there is a silver lining, and that is that mobile network infrastructure is one of the most dominant connectors of internet for users in Africa, where we see 3G and 4G connections accounting for over 90% of the internet connections in Africa. So digital health systems should be leveraging on mobile health architectures and cellular systems to be able to provide some of these services. So it's quite possible that somebody doesn't have access to reliable electricity, or may not even have electricity to their homes, especially in rural areas, but they definitely have mobile or cellular connectivity. And you might wonder, how do they charge their cell phones? So this is actually a kind of business model where you have people in very rural areas that can go and you can charge your cell phone, but you can see that at least the access to the internet or to connectivity is something that we can definitely leverage on when we're trying to implement digital health systems. So in our work, we envision something called a 5G enabled digital healthcare system. And this is what we've been working on at the University of Cape Town, at GCT. The reason why we're doing this work is because we see four potential avenues of impact. So the first avenue of impact is the ability to foster the development of the relevant digital health technologies and services. As we can see, the uptake of ICT and the use of 5G, of the Internet of Things, and low-cost computing and mobile applications is not really yet prevalent in African clinics, hospitals, or healthcare delivery contexts. And if we can increase the use of these ICT services and technologies, we believe it will be much easier, or the barrier of entry will be lowered, such that we can deploy digital health platforms, especially those that are low cost, designed with the African context in mind, and that can be reused and utilized at different various locations in Africa. So our second potential impact is, we know that this is not going to be easy to develop such an ecosystem, but I think through the exercise of doing it, we'll be able to identify some of the technologies that would enable us to meet the specific needs for some of the target regions, not only for their benefits in the digital health context, but it might also create new avenues of enterprise. For example, the localization of technologies or the creation of small and medium enterprises. This is one of the outputs that we envision such a digital healthcare ecosystem could benefit in the region. The third potential impact that we see is being able to identify the barriers and obstacles or hindrances for the adoption of digital health platforms and applications. As I've mentioned, there isn't wide use of digital health in many African countries. In South Africa, you could say there is access to digital healthcare systems, but it's very limited to the private sector, and this could be the same in other African countries. So, just an anecdote, we were visiting a rural clinic in the Northern Cape, where we were doing a needs analysis to see what, in a typical clinical environment, what is it that they're currently facing, and what would you need to actually enable such an environment to be able to offer digital healthcare systems. And when we were doing this needs analysis, we came to understand that actually they had implemented the digital health, or at least an electronic healthcare record system, but they had stopped using it because it was mixing up the patient IDs. So, for example, if they had given a patient a particular patient ID, another patient would come and they would get the file of another patient. So they just stopped using it and they went back to their old paper-based system where they have a room with a cupboard and medical health files. And they couldn't even get help from the Department of Health, in this case in the Northern Cape, because the person who had, or the company who had been employed or contracted to deliver that system was no longer under the pay of the department. So it's not that there aren't any initiatives being implemented, it's also that things like long-term sustainability, being able to offer, let's say, things like services for clinics who might need technical help. So these are some of the barriers that we've seen, we've identified, that one needs to think about when they're developing their digital healthcare systems. And then obviously, the final impact that we envision here is improving public health. Not going to solve all the problems with digital health, but at least we could make a dent in alleviating systems that are hugely burdened. This would support the UN SDG goal 3 of improving and ensuring health of all citizens, and especially in rural and underserved communities. So these are the 4 reasons why we are doing some of this research, where we aim to develop a secure and intelligent 5G digital health testbed for the evaluation and the validation of telemedicine and digital health applications in Africa. And our motivation is that we would like to create a platform for the validation of these applications, and we'd also like to go beyond that and drive the adoption of these healthcare ecosystems so that they're used in the mainstream. Our main focus is to ensure that we think of the African context, think of the specific problems that are going to challenge the different locations in Africa, one of them being having systems that are effective but also low cost and scalable. So here I say 5G, but it's not necessarily that it needs to be a 5G system. We would like it to be 5G because, that is the highest level of cellular technology, at least that's available on the market today, even though some people are doing research already on 6G. But the idea is that in our architecture of a digital healthcare system, we envision multiple domains where you have the data acquisition domain, where you have your various devices that could be providing some sort of collection of data, health-related data, and then this information would need to be transported across some sort of communication infrastructure. We think 5G, could be 4G, could be 3G, could be whatever is available in that particular location. So we have this access network based on cellular technology, core network and transport network domains. And then we have a data storage and processing domain where the data that has been collected from the end users can be processed, can be and stored securely because it's health data, and we do have considerations about the security of such data as it's being transported, as it's being processed and stored. And then we have the data retrieval domain, where this data becomes useful for a particular healthcare application that one might be investigating. So when we're talking about the experimental test beds, we actually have one deployed at the University of Cape Town, and I'm working with a very close colleague of mine in the Faculty of Health Sciences, Department of Division of Biomedical Engineering. So we had three options in terms of our communications infrastructure, where we could deploy a 4G, a 5G, with a non-standalone architecture, which means that the access network or the wireless technology is 5G capable, but it still relies on a 4G management system in the core. And then finally, we go for a fully complete 5G solution, which is the standalone. And we've been able to play around with various different low-cost equipment that allows us to achieve this, particularly software-defined radios, relatively low cost compared to the commercial counterparts, and also leveraging on open source networking stacks to achieve all three kinds of network deployments, so 4G, 5G with the non-standalone, and 5G with the standalone. We've gotten quite comfortable with the different open source stacks, where we prototyped and validated and benchmarked the performances of these, and we published some of these results in various areas. One such publication was at the Wireless On-Demand Network Systems and Services Conference. The results were not great compared to what you would typically see in a commercial network because we're deploying an in-house private network. However, they are a starting point for us to actually utilize the test bed to validate some of our digital health applications. So the idea, as I mentioned, is about the digital health applications in the test bed. So we use the 5G experimental test bed to be our base or our foundation for the end-to-end digital health test bed, where we see the connection of various end-user devices, typically medical devices, that are collecting medical health information, and then the transportation of that data across our experimental test bed. We want to create a sophisticated management and orchestration system that utilizes some of the concepts of 5G, such as network slicing, so that the applications can get the required quality or level of service from the network based on their requirements. And here we have a PhD student who's working on the development of these network slice templates based on the creation of data sets that's coming from the various different application devices, devices in the access network domain. And we have some preliminary work which was recently presented at a conference in September at The main idea is that if you can create a large enough data set, then you can use machine learning techniques to train your management and orchestration system such that it creates the required network slice templates for your different digital health applications. Another application that we've been looking at is a virtual clinic system. This one is quite important in the sense that it allows for the actual telemedicine concept to be validated over the digital health test bed. And here we followed a user-centric design approach where we looked at the specific requirements for clinical contexts in South Africa, interviewed a bunch of stakeholders, doctors, nurses, healthcare providers, so that we could develop a system that is fulfilling their particular requirements. We implemented and evaluated the system, and we even did this in a rural and remote and underserved community, as I mentioned, in the Northern Cape. So we've done some extensive evaluations of the system in terms of its ability to deal with various network performances, as well as the usability of the system with practicing doctors and nurses. Some of our results have been published at various conferences based on the system, and here we have a now PhD student who is working to integrate the system into another system that is used by the Departments of Health in the provinces. And then we chose an application that would actually utilize 5G. And here we looking towards the development of telerobotic services. Initially, we looked at the idea of telehaptics. Telehaptics just means being able to send XYZ coordinates from a robotic, or let's say from a haptic device to a robotic arm, and then also send, let's say, the change of these coordinates in time, as well as the acceleration, etc., and then being able to perceive any barriers coming from the robotic arm side. So you see it's a two-way communication that needs to be facilitated in really low amounts of time. So the low latency aspect of 5G can be exploited with the use of this particular digital health application. And here we had some initial results that were published at a conference in Greece last year, where we did a prototype, not a real robotic surgery system, but at least we were able to understand what were the requirements of the network were to be able to facilitate this kind of communication where you need to send multiple data points and receive feedback with really low time constraints. This is some of the other publications that we've been able to develop based on some of this research work. It's still ongoing. We are having a few masters and PhD students that are working on some of these things. And as we're looking forward to the future, we'd like to expand some of our digital health research to enable other more sophisticated things like AR and remote surgery, so as a kind of like extension of our telehaptics system. And here we are in talks with one of the hospitals, Critical Hospital, where they have launched a AR training facility where students can learn about robotic surgery and the use of AR to enhance, augmented reality to enhance robotic, surgical procedures. And we want to implement that work by ensuring that some of the systems that they're developing is supported by a reliable communications infrastructure. And we've also started looking at emergency telemedicine, where we've seen that around the world there is this concept of a 5G smart ambulance. We want to see how such a system can be developed within the context of Africa. These are just some future research directions that we are looking towards going into. And I think that takes me to the end. So I hope you got a good overview of what some of the challenges are, what some of the potential impacts could be, and what we've been working on at the university. Our idea is not to just leave these results as publications or masters and PhD theses, but to actually engage with, for example, different stakeholders like the departments of health, the Ministry of Health, so that we can show that some of these things are possible and create an ecosystem for the larger proliferation of digital health ecosystems. So, yeah, so thank you. If there's any questions.
Thank you. We've got time for a question, a quick question or two. Any questions? Yes, go ahead.
Thank you very much. I think it is absolutely important to go to physical structure, rural structure, and rural combination into the cities, and then on the other side, digital twins or digital hands or digital development together and so on. I see that has been done a lot of work. You are talking about augmented reality, virtual reality, and something which will be helpful if in rural area, if it's in a station is available, maybe is possible that the patients can be there, at least this small way to be, and then go with virtual reality, with augmented reality, maybe the doctors in the physical, hospital can maybe be helpful. I think this is this parallel form, digital and physical together. This development is in the way to do that, right?
Yeah, thanks for that. That's quite right. The challenges we see are, for example, low reliable access to the internet. But as we mentioned, we leverage in rural areas. We leverage on. There will always be some kind of connectivity, even in rural areas, as we've noticed. Maybe not in the middle of nowhere, but where there is a mass of people, they will at least have 3G or 4G or 5G. And you might not be able to do the super duper things like AR or telerobotic surgery, but you can still do virtual consultations. Or if you can't do a video consultation, you can still transmit things like heart rate, blood pressure, those low data rates creating health related data to the doctor so that they can still be able to access people who are in rural areas. I didn't mention it too much, but in South Africa, most of the doctors are in urban centers, and most of the doctors are working in the private sector. So a large section of the population, I think almost 79% of the population, only has access to about 14% of the doctors. So there's a huge skills shortage, and something like virtual consultations, it doesn't have to be AR, but whatever it's capable, whatever you can facilitate for that location would go a long way beyond what is currently there. Okay.
Thank you. I think that's all the time we've got. After the questions for Joyce, please ask during the coffee break. Okay, great. We need to carry on with the paper presentations. Yes, thank you very much, Joyce.
Nee, wat was Ach nee, guck mal, comment for you. Guys? Thank you. Good morning. So I will share our work on green streaming, on sustainability video delivery over IP networks. My talk is called Towards Sustainable Video Streaming, Evaluation of AI Approaches for Content-Aware Encoding. So what we've done, we have evaluated machine learning models that should help us to optimize video encoding, to reduce bit rates, and to provide a more energy efficient and sustainable video streaming towards clients. So I would like to start with content-aware encoding and basics and basic motivation. So what do we have? We do have different kinds of medias, right? You have animation, action, nature, documentary, and sports as some of those examples, and they all have, let's say, different characteristics like complexity and redundancy, which are the two most important parameters that we are looking into. And what we like to do is we try to analyze and understand complexity and redundancy within videos. So for instance, in animation, there are typically parts of the video with the same color, with not that much changes between the scenes or between different seconds compared to, for instance, also actions where everything changes scene by scene or even frame by frame, which causes more heavy, say, work for the encoder to compress data. And today, or yeah, almost today, a lot of video encoding is done on a static set. So you have a static description of how you encode your content, so resolution and bitrate pairs for adaptive streaming, and they are set, let's say, they are all the same for all the different kinds of contents, which leads into an inefficient way of encoding content and then also store and transmit it. So that's why we would like to do is content aware, so adapting the encoding settings to the specific type of content, and we go even further with per shot and scene encoding, which I will be talking in the next couple of minutes. So where do we start? So basically we start with per title encoding. So per title again analyzes the content, traces all the networks in there. We can then calculate quality metrics. There are two of them, which is SSIM and especially EMAP score. So EMAP score has been introduced by Netflix. And it gives you a score between 0 and 100 and describes the quality of experience for the viewer. So as higher the score, as better the quality of experience. And what you can do, you can use different, this is what's shown here. So we have different resolution and bitrate pairs like full HD and down to 240p resolution stuff. And you use the VMAP score and you calculate your encode content with the different settings. With, say, offline. And then you calculate the VMAP score, and then you can draw a graph of quality and bitrate, and you can create complex hub. You can find optimal points where the specific parts of quality and bitrate match best and gives you the best VMAP score and, so to say, the best quality of experience for a specific resolution and bitrate. And this is called per title encoding, so you can optimize your encoding on a title basis or on a specific part of content. And the bad thing is you have to do this offline. So you have to, let's say, try all the different pairs to create the ideal set. And this is very heavy on a computational perspective and takes a lot of time. So what you want to do is, you want to do this automatically and in a, say, predictive way. So this is what we call AI-powered content-aware encoding. So we have worked on a solution which is called Deep Encode. And what we try is, we try to predict the best resolution and bitrate pairs for a specific content and for a optimal bitrate ladder. This will help us to prevent us from doing all the testing codes that you have seen before in title encoding. Let's go through it. So there is, of course, the video. this is what I told you, this is per title encoding. We can do this on a per scene basis. So as soon as we are not required to do the testing codes for all the content offline, we can do this on a machine learning based model, let's say on the fly, so more or less in real time. We can also separate a specific part of content by scenes or even by shots. So scenes, for example, if you were in a news show and the guy is talking about something and it's almost a very static part, and then a moment later there is a summary of the soccer game, and this is the same content, let's say, but different scenes, and that's why it makes sense to also cut down the content or the encoding specifications up to scenes, or maybe even to shots, and you can also do this by frames, but this is just on a technical basis, right? You won't do this. How's the workflow looking? So basically we start with the source video. On the upper left corner, we do a complexity analysis. This is done on the fly. Based on the pre-trained models that we have, we can adapt our machine learning models there and create a prediction of the best bitrate and resolution pairs, which we call the encoding ladder, and this is then adapted to the workflow, content is encoded and delivered to the customer. And all this stuff already runs in real time, so we can also adapt this to live streaming. How are we going to approach this? As I said, in the first step we have to do a similarity analysis, so we compare frames and compare scenes within the content. For instance, by using color histograms or structural image analysis. Based on the data, we can measure the similarity score of all the stuff, and basically fed the results in a neural network and try to figure out if the frames are similar or not. And if they are similar, we move on to the next frame, so we can use the same encoding for the same frame, or even for a couple of frames, which you then call a scene. Or if they are different, we maybe should split the content and adopt a specific encoding setting up to this point, and then analyze again and start with another prediction for the upcoming content. Let's just summarize it. So we check if they are similar. If yes, we put them together. If not, we split. So we're ending up in different, we call this the complexity group. So we have figured out that there are, in this case, here 3 complexity groups, and then we can adapt our models and can do the encoding of the different complexity groups with the same settings for each group. So complexity group A has another setting than group B and C in this case. And to give you some insights or some examples. This will lead to 13th of the video play time to do the analysis. We can reduce the bitrate up to 68%. Of course, this really depends on the type of content you are trying to encode, but these are, let's say, the best case values here. And what is important, the prediction of the expected quality of experience is accurate up to plus minus 2 VNet score points. So meaning you won't be able to see a difference in the result from what we predict compared to what you might have to test encode with a different type of approach. So we can really skip all those heavy encodings. We can predict this and are at least as good as the calculation. Okay, and then, so in the beginning I talked about green screening and sustainability. So what can we use with those enhanced video encoding mechanisms? This is a drawing of a typical streaming supply chain with maybe some measurement points where we can try to understand how much energy is consumed by all the specific steps here. This is ingest encoding and pre-processing. So typically we've talked about this when we talk about content-aware encoding, and then of course content needs to be packaged to Dash or HLS, so to bitrate stream formats, and then it gets distributed in transmission via CDNs and DX networks to to the clients where content is consumed and played back. And so we did some measurements on power consumption to get some ideas of what we can really save when we apply content aware encoding. So on this chart here is just giving you an idea of the consumption of watts versus brightness of your end device, which is that there is a direct correlation between the luminance of the display, of course, and the watts consumed. And having this in mind, we can also optimize our machine learning models to consider this when creating the different encoding settings. And on the right, there is a table showing the watts consumed for a standard encoder versus AI-based encoding as introduced before. And what we can see, especially in UHD content, we were able to save up to 30% of energy during the encoding process. So we have to, as I said, we have the different steps. We need energy to encode, we need energy to package and distribute, and we need a lot of energy for all the end devices to play the content, which I try to understand where real energy consumption happens and how they are related to each other. And yeah, just another drawing. This is also again a standard encoder versus A-based with received encoding, HD versus UHD. You really see the gain here that we can make based on machine learning models. And last slide is the all the stuff here. This is the comparison of shot-based encoding versus our VMAP comparison, and you see that the bit rate, so the blue curve here, this is the deep encode bit rate, which has been predicted by our machine learning model. And if we compare this to the broadcaster bit rate, which is in magenta here, then you see there's of course variation because we really apply it on a percent basis. And overall, we were able to have the same, let's say, the same VMAP score with significantly lower bit rate, and it helps us to reduce storage costs, to reduce the bit rate it needs to distribute to the clients, and at the end helps to save energy. And that's it. Thank you.
Okay, now time for questions.
There's a question?
Yes, if you broadcast natural videos, you have the problem that they are made with different illumination. And we said you will make training. You want to get a very high encoding rate, professional rate. Is it so if the illumination changes that you can nevertheless assure that the compressing rate is high if you make the training with different videos with different illuminations? And what can you say?
Okay, so one thing about the broadcast. So we are here in the IP domain, so there is no stat mobs or things like that where we have to put the data in. We were really able to adopt a specific encoding setting for parts of the content, so you can even split the live stream into let's say different chapters and adopt and apply different encoding settings to this. And this also applies to the let's say predictions that we made for finding the best encoding parameters. It's not only about bitrate or resolution. It really depends. We usually throw in more than 50 parameters, and the machine learning model tries to figure out what's really the best setting. And it depends on how's your workflow looking, what are your end devices, what's your content, right? Type of content, and all those things. So we put this stuff together, and then the machine learning model provides us with the best solution. So it's yeah, a very adaptive approach there. Another question, yeah?
I have a question about the deep learning aspect on the end. how does this affect the device that is decoding the information that's being received?
It's a good one because there will be devices which won't be able to switch between the different settings to decode the content, especially when you refer to MPTS and stuff like this, so you can't change it. We are adopting this to MPEG- or HLS streaming, where you can have in the HLS discontinuity markers to signal the decoder, okay, content might change, and then the player is able to reinitialize the decoder for playback, and then you can also change codecs and resolution and all those stuff, even on a live stream basis without any interruption. The same works for MPEG-, where we have this concept of media periods that allows you to.
Thanks.
Okay.
Thank you very much. Here. And over the presentation certificate. That's this. Here. Okay, one minute. Okay, next presenter.
Contribution and general overview, then hyperparameter tuning, data set description, one-hot encoding, performance matrix results, and references. So, first of all, what the recommendation systems are, as we know today, we have a lot of data streaming on an account. This, because of this enormous amount of choices that are available to the users, they are simply in confusion for selecting the desirable content to watch. So with this problem, with this boom in the content, recommendation systems, they are becoming an integral part of many social media platforms or internet or business, so that we can get the right content that we want to actually watch. So recommendation systems, basically these are the algorithms that help a user to choose the best alternatives based on their preferences. That may be the previous watch history, that may be some demographic data, or similarities to other users. So basically there are three types of recommendation systems. We can say broadly, we can divide it into three categories. First is content-based filtering, then collaborative filtering, and hybrid systems. So what is content-based filtering? It is a recommendation method that uses the target user's profile and video content to predict the target user's choices, their preferences. So video is recommended on the basis if its content is similar to what the user liked or watched before. Collaborative filtering is a technique that we use in the systems to predict the user's preferences for a particular item or product based on their past behavior or interaction with the similar items, as well as the behavior and interaction of other users who have the similar choices with that user. So this is achieved by recommending a video to a user if like-minded users have given a positive rating to the similar content that they have watched. So these are the just broad view of the collaborative filtering, two types of it, memory-based approach and model-based approach. Memory-based approach further divided into user-based filtering and item-based filtering. So basically, we can filter it based on the users and items that are being watched. So model-based approach that is use matrix factorization. So what is matrix factorization? It is a technique which computes a latent factor model of a system based on user item interaction. These user item interactions can be represented as a matrix with users on one axis and items on the other. In most recommender systems, interactions are rated by the users for movies, but can be different data as well as such as confidence levels. So, what the hybrid approaches are? To improve the accuracy for user choices in recommendation systems, we use combination of both types of approaches, content-based filtering as well as collaborative filtering. So hybrid recommendation methods combine both users' feedback as well as the consumed video content. That is basically history of the user. So what the problem is when we are using any recommendation system? If a user has already on the platform, already on the watching the TV, watching the video content, then he has some past history, some preferences, some likes, some dislikes, some ratings. So based on that, it is very easy to recommend the new content to that user. But in case when the user is a new, he has no past history, he has no data, no preferences based on the system can recommend something new. So that is called cold start problem, when there is no recommendations. So we try to explore this using some problems. So we already discussed what the warm start and what the cool start is. So there is some literature that we have reviewed starting from the year 2016, some paper that is from 2018, then 19, 20, 22, and so on. So what we found from the literature study, it has been observed that most of the previous laws are based on recommending top movies to the users, and few of them are based on how to recommend new movies to the new users or the recommend movies to the new users. But until recently, many research efforts have not focused on including the metadata of the user. That means what type of user are there who are starting to watching the movies. So we try to include the metadata of the user to complete the model. So these are basically objectives. That means we are trying to propose a representation method for user information to improve the recommendations. So contribution, what we have actually done, we have used user rating matrix and item content matrix to solve the whole start problem. In addition, we have added users metadata to the recommendation model, which become important while dealing with the cold start problem. For this, we have added the user content matrix for our user metadata to further improve the implementation. Additionally, before building this implementation model, a scaled version of user rating matrix and user content matrix is used to normalize the range of matrix features. So this model we named as the enhanced scaled collaborative embedding regression model. So here we are using various features like genres, audios, action, visual appearance are used for this model. So this is basically the overview. What is this model? So if we see, we start in from the video content, and then here from the user side we have two metrics, that is user implicit ratings. These are the users which are already on the platform. Then we have the new user demographic data, that is for the new users. So here we are combining three metrics, and from these three metrics, by training the model, then we are getting the actual preferences for our predictions for the user. So this is basically hybrid model because we are using the matrix factorization method also. So these are some dimensions that we have taken. So by factorizing the rating matrix, the model learns the rating factors that best explain the observed user interactions, and these matrices serve as a compressed representation of the original rating matrix. The model can use these learned rating factors to predict missing ratings or generate personalized recommendation for the users. So here we are doing hyperparameter training. So by using Bayesian hyperparameter optimization technique that is obtained. So it is just like a software framework which uses a model-based approach by finding the optimal parameters. So how we are organizing our data set? We have taken a real world data sets for movie lens. We have divided into three subsets: item content matrix, user rating matrix, and user content matrix. So we have this. So these are the number of movies for cold item, these are the number of movies for warm item. So number of users, cold users are 4,609, for warm users are 65,000. So these are the features: genre, object, scene, actions, and then audios. So what the user demographic data we have added, that is age, gender, and occupation, that is user for the choices. So then we have used the one coding that is used to import categorical features of the user's demographic data as a one numeric array to create the user content matrix. So these are some mathematical representation of content coding. These are the performance matrices that we are using. One is mean, average, precision, then normalized, discounted, cumulative gain, and item coverage and Shannon entropy. That is measured for the uncertainty or randomness system. So if we see the results after using the user data incorporated with the user content and the item content. So here we are getting, while we are using Bayesian optimization technique, we have taken three cutoffs: 5, 50, and 30. Because if cutoff is less, then also we will not get the accuracy. If it goes beyond the 30, then also. So here we have with 5 items both and 15, 30. So if we see here in our scaled, advanced scaled version, so if we see the scene objective function, we are getting the better results when we have cutoff list or threshold value 5. And at threshold value for LDCG, we are getting the higher grade greenish. And these highlighted content that is showing at which cutoff list we are getting the better results. So if we analyze this, so regarding all accuracy matrices, the enhanced scale model performed better than the scale. So there are so many 41%, 47%, 30%, 39 and 27% is better.
Thank you very much. Time for questions. Yeah, thank you very much. Okay, for certification certificate here, please. Thank you. Next presenter, please. You can start.
Hello everyone. Today I'm going to talk about text mining application. By the way, I'm Mustafa Ömer from Icecet Technical University from Turkey. Let me introduce the concept first. In global world, as we know, the consumer trends are getting more and more online rather than physical, and it leads to growing importance of e-commerce websites and increasing marketing benefits from them. So, as a result, customer reviews, also known as E1, carry not just a valuable feedback for product itself, but also positive experiences such as quality, price, for potential consumers and manufacturers. And customer reviews can also be used for opinion mining, so analysis of star rating and comparing them with the review text may provide outlier reviews and positive negative feedback detections as a sentiment analysis of the consumer, to the customers or to the manufacturers. On the other hand, the text mining or knowledge discovery from the text, KDT, and it analyzes the text by machine intelligence. It's an algorithm combination of the techniques such as information retrieval, information extraction, or NLP. And machine learning approaches such as clustering, classification, dimension reduction are very useful concepts for processing and analyzing such a kind of large-scale data sets to learn from the text. Let me talk about some statistics about Amazon.com statistics. This is the most reviewed product on Amazon.com. It's a Fire Stick. And the second one is mostly ranked products ever on Amazon.com. It's Apple AirPods earbuds. And one of the highest ranked products on Amazon.com again, it's a mug. It's a Yeti mug. These are some popular products on Amazon.com, as we know. And the total number of reviews on Amazon.com is over 250 millions, and it's still in counting. And the most prolific Amazon.com reviewer is a library, as much as I know. She's having cluster, and she did a lot of book review on Amazon.com. And finally, I want to ask if you have any knowledge about this. Mostly have full review, because in Amazon.com we have also some reviewable helplessness statistics, but I don't have this data yet. Let me come to the main object of that study. This paper proposes a customer review segmentation pipeline using text mining methodologies, and I will present a case study for a product called Minute One. And this product had a lot of reviews on Amazon.com, such as review 300 and review 24. And let me talk about the research lab. When we look at literature, there are some similar works within, which is similar to my work as well. Reference 7, 8, 9, and 10 contains, also 11 contains similar works for text clustering, to cluster the reviews on some kind of e-commerce website. Also in literature, there are some other types of works or papers which includes different approaches, such as reference 12 and reference 13. In these studies, clustering is not only directly applied on the data set, instead they are applied along with the dimension reduction or as an algorithmic pipeline in combination with supervised learning methods. And here is the summary of the literature survey. And as a result, no pipeline is carried out via dynamic vectorization, dimension reduction, plus clustering algorithms, and no similar way of segmentation come across. So the novelty of that study is that Bullitt may know that idea while comparing it with the existing papers on the literature. Let me explain the proposed approach that I proposed in my work. It's an algorithmic pipeline, as I mentioned earlier. In the first step, the data set is scrapped or retrieved by bias scraping. Then some pre-processing applications are done on the data sets, such as static learning, text translation, etc. And after that, some NLP operations are applied on the data sets. Then the data set is converted into vectors by using Dynamic. And of course, we have a multi-dimensional data sets after we vectorize the data set. So as a result, I used dimension reduction methodologies to decrease the dimensions, such as TSNE or PCA. And finally, I did cluster the comments or customer reviews by using K-means and DB-scan, two different clustering methodologies. And as a result, when we look at the clustering output, we will easily interpret the result of the clustering to see the failure nodes. Dynamic is, just like we know, is a supervised method which converts documents into vectors. And moreover, in Dynamic, it's possible to measure the cosimilarities between documents by this method. For dimension reduction, as I said earlier, I used two different methods, TSNE and PCA. Basically, they are embedding the high-dimensional datasets into lower-dimensional datasets. And when it comes to clustering, I use two different methodologies as well, K-means and DB-scan. K-means is a partition-based method, and on the other hand, DB-scan is a density-based method. These are different methods because PV scan is able to unearth the non-convex clusters or some clusters which has overlapping convex source. On the other hand, K-means is not able to unearth the non-convex clusters. Let me come to the data sets. The proposed pipeline is carried on a review data set, and this review data set is brought from Amazon.com, and this data set only contains critical category feedbacks, not positive feedbacks, and the product is a mini drone for kids, of course. And the data set contains 589 customer reviews, and they include over 1,000 sentences and 24,000 words as overall. And along with the text, the review dataset has also have 5-star ratings for this product. And there are some statistics about the datasets. Histograms depict the statistics of the datasets. For example, mean of words, mean value of words per review, and standard deviations, of course. And on the left side, we can see the word cloud of the dataset. And when we look at the word cloud, the most frequent words in the dataset given in the bigger font sizes. After I applied the proposed pipeline on the customer review datasets, the clustering output is obtained with a labeled representation. By using two different dimension reduction and two different clustering methodologies, I got 4 different clustering schemas. And here are the summary of the outputs in the table format. As we can see, we have some clusters in each schema, and the number of clusters in each schema varies when we use different algorithmic pipelines. And moreover, I got mean star values for every single review cluster, both for TSNE and PCA. So number of dimensions is set as 2 for easy visualization. And I got average and standard deviation values for star values. And let me show the output or the visual output of the clustering schema. By using 2 different dimension reduction methodologies and 2 different clustering methodologies, I got 4 different clustering schemas. For K-means, I set K as 4, and for TSNE output, and similarly K is set as 3 on PCA output after using the method, of course. And the best clustering schema, according to the method, for DBScan is for both DBScan and K-means. I had some trial and error process and decided for input parameters for DBScan as well. But the best clustering schema is for DBScan plus PCA.
Thank you very much. Questions?
Thank you very much for your talk. So, who will use this type of information in the end? Is it like you want to improve the description of the products, or do you want to give it back to the seller of the product to give their feedback, or what's the idea?
Well, the idea is that the information which is coming from the clustering output is going to be for potential customers and product developers in terms of, for example, failure modes or etc.
And do you have any clue how to cope with like fake ratings and fake entries? Because I think whenever I read a Amazon review, I think like 30% are too optimistic, too good, 40% are really overcritical of the product, and the rest is maybe a little share, but you always need to find the right.
Well, some data sets, as you said, contain some kind of noise data sets, noise data or outlier data. So it needs to be discarded before the process is applied. But I haven't done any kind of approach for this right now, but I'm planning to enhance it.
Do you consider like the ratio between very good ratings and very bad ratings? Because you excluded all the good ratings. I think you focus on the good.
Yeah, because the idea was that extract the favorite modes of the products.
Yeah.
That's why I have just considered the critical category feedbacks, not the positive ones. So because the positive ones contains positive feedbacks for the product, so it will not be useful for us to extract the favorite modes of the product.
Thank you very much.
Presentation certificate for this. Next presenter, please.
Hi everybody, my name is Abdul Bayrak. I work for Athletic News Platforms. It's a company from Turkey, and these are my co-authors. The title of our work is Product Completion with Association Analysis, Recommendation System Application for an Insurance Company. The content of the work will be, first I will talk about the problem definition, then I will mention the data we use, methodology, the results of our methods, observations, and future work. As you all know, commander systems is all part in our world now. In every application, almost we use commander systems. Most of the companies like Netflix, YouTube, Amazon, they have great commander systems. But of course, there are many different kinds of commander systems. Lately, there was another presentation before me, so she mentioned very well the detailed explanation what they are. So I can press this part. The commander system can be rule-based or item-to-item, user-to-user, or topic-to-topic systems. So there are many different kinds of commander systems. One of them is market basket analysis. It is not it can be, in real cases, it's not just one of the systems for commanders, especially since there are kind of hybrids of systems. So that can be just one part of the problem. So it keeps getting by itself. So I'm sorry. And of course, it's not basic, some simple procedure, so it has some problems. Firstly, the categorical data, using of categorical data may be too superficial, because mostly we use the encoding, so 0 and 1. So some values could be in between, so we just say 0 and 1, so it's a superficial. As a result, they may not be diverse enough of the result of this method. So they may recommend similar products. And what we did is the classification here. We applied Icecet theory so that we change the range of categorical values. So instead of just use 0 and 1, we give range between these values. The data we use 953 unit users and we have 8 different benefits for this insurance company. And we eliminate some of the benefits because they were the same. And we transform this tabular data into transaction. And the values represented as 104 rule-based, association-based model preparation of it. We applied 3 different methods: a query, class, and a big growth for rule mining. These are the results of these 3 methods. You can see the number of exaggeration rules, number of iterations, etc. And as I mentioned, we use classification. So instead of just 1 zeros, we give these ranks. So these are the values from the data. So instead of just 1 zeros, we have a range here, 0.8 and 1, and it is going like that. So we, as a result of classification, we calculate the membership or not, it is a member of not this range. And after applying classification, we saw that the number of rules and item set increases. And this was our aim actually, because we want diversity. So this is how we increase the number of rules applying classification. As a result, as I mentioned, there are limitations in rule mining, association rule mining. So we try to overcome applying classification to increase the diversity. So this is basically what we did. As a future work, we will apply this method in different domains, not just insurance. So it can be applied in almost many different domains. And we will use A/B testing to see the results more clearly. So, thank you very much for listening. If you have any questions, I'll come back. Thank you very much.
Okay, time for questions. Okay, the question is as follows. Is it following based on improvement of existing systems or just contribution to the backup knowledge?
Of course, it's we don't contribute to the research actually, we just apply it in a different domain. So, as I mentioned, what we try to do is make it more diverse. So, it is another option, so it's an alternative for an existing method. So, if you give similar results, you may add classification to give different results, and you can measure if they are better or not. So, it's just this option it is.
Oh, yeah. I saw that. I displaced it.
Good morning, everyone. It's my pleasure to present my research titled Long-Nodule Segmentation in Low-Dose CT, Modified 3D and NUNet with Unified Photos. My name is Shu Guo. I come from Taiwan. Where is Taiwan? Taiwan is in the Asia. Taiwan also called Formosa, means beautiful. So Taiwan is very small and beautiful. However, more importantly, Taiwan is safe. You can walk outside at night. Okay, so welcome to Taiwan. Okay, let's come back to my presentation. This is the outline. This is the outline of my presentation today. Let's start with the introduction section. Motivation and the issue. Motivation, as well known, lung cancer has the highest death rate among all types of cancers. Even in Taiwan, it's similar. Okay. And the medical research indicates for lung cancer tumor around 1 cm, surgical resection achieved a cure rate of 85% to 90% with no recurrence within 5 years. Okay, there are many indicators. There are various tools for the detecting lung cancer. However, low-dose CT is internationally recognized the most effective one for early lung cancer screening because it can detect lung nodules smaller than 1 cm, even less than 3 mm. I'm sorry. Okay, this study we will resolve 2 problems, 2 issues, then create effective tools for segment the lung nodule. Here is the, we call the main nodule with the small volume or low He value as the hard case. Here show an example. Okay, second issue, the widely used NNUNet in the medical segmentation task has a problem, segmentation gap problem. So we will deal with this problem. Okay, answer. This is our system framework, including 3 main processes: pre-processing, clotting, and segmentation deployment model. All the CT scan will be pre-processing. Resampling resampling because the CT scan may have the different voxel spacing. So we need for the same physical meaning of the data, it is necessary to resample each image. Here we use the median of our CT scan spacing. The HU value of the image also has a problem, so we normalize over the HU value of the image. Cropping. To reduce memory requirements during the running time, all the scan will be cropped into the small pages. There are two cropping methods. In the training time, we will use randomly crop the local region of the nodule. In inference, the sequential cropping the page from the left to right, then top to bottom is used. Section deep learning model. We build our model progressively based on the NNU net, then residual NNU net, then more further improve it into the modified residual NNU net. This is the original NNU net, consists of one encoder and decoder. Its problem makes the segment, the nodule is very hard. So we improve it first in the encoder convolution with the residual block. In the decoder, we also implemented a deeply supervision in each layer to strengthen supervision capability. Then further improve it to mitigate the segmentation semantic gap. We implemented a module MSDAN to connect low-level information and high-level information. This is the MSDMN structure. Dilated residual block extract the multi-scale features. Gap adaptation will be applied for spatial focus. For the detailed structure, please read my paper. Regarding the loss function, we use a same unified focal loss, which consists combine the cross-entropy loss and the dice loss to increase recall without compromising precision. Evaluation metric. We use the common matrix dice coefficient to verify our system. And to verify the model generalization ability on different testing databases, we also use careful cross-validation to verify our system. Data set. Here we use two data sets, public data set and private data set. Public data set is used to compare our system with other system performance. So we adopt the commonly used public database LIDC, which is established by the National Cancer Institute of the United States. Private data set, we use the NCKUH database, which is established by the National Chungho University Hospital. This hospital is the most famous and biggest hospital in southern Taiwan. Some information on public data set shown here. Private data set consists of two sub-data sets, patient database and medical examination database. Patient database collect the pathological data from the clinical slice examination. The medical examination database gathers suspicious nodule found during clinical imaging examination. Some information shown here. This table and plot summarize the count based on the data attribution. Experimental. The experimental environment, first, the ratio of the training data to testing data is 7 to 1. We also use the data augmentation, including rotation scaling mirroring. Some information of the parameter software and hardware shown here. This is the operation study table. This table shows the residual NMU net with a uniform loss. Attention gap and dilated race to graph has the top performing model, which dice coefficient is 83.5%. This table shows the performance of the 3 different databases with the 5-fold cross-validation discussion. In this section, we will discuss our model's performance under various conditions. This table shows our model is superior to other methods which is introduced in the literature. This table shows our model based on the size nodule, different size nodule. As well known, the nodule size is an important indicator in the clinical lung cancer diagnosis. So we analysis it. It shows our method can perform well at any size the nodule.
Thank you very much.
Thank you.
Questions?
Question?
Sorry, I'd like to make sure that I understood the size of the initial lung image. I saw 400 by 512, 512. I want to make sure that 400, is it the size of the number of channels, or is it one after obtaining a running picture?
You mean this one?
No, go way back to the beginning. I saw 400 by 512.
405.
Go back.
Go back.
The lung image, go way back from the very beginning.
Very beginning?
Yes, where you show the images of lung.
Please let me know. Okay, I just put. Which one?
Yeah, keep on going back. I will stop you when you get there.
Up.
Again.
Okay.
Again there. Yeah.
This one?
Yeah. No. Keep on going.
No?
No.
No?
It was only here. Yes, it was here.
Oh, okay.
I just want to understand the 400.
You mean the spacing?
Yeah, the 400s. Like I want to understand the 400s term.
Oh, 400. Okay. The scan from here to here, about 30 to 300 to 500. The scan slice. CT scan.
Okay.
Yeah. It's dependent on the spacing, maximum spacing. Yeah. Different CT scan has a different spacing. We need to normalize it.
Thank you very much.
Thank you.
You can start.
Hi everyone, I'm Leon. I'm going to be talking about my project on a dual radar system for predicting collisions at uncontrolled speed. So, we're going to start with an introduction, followed by a design section, and then move on to some simulation results, and then finally the implementation of a test rig, and then the results for control and uncontrolled testing. So, the problem, the unregulated intersection is one where there's no traffic lights that regulate the flow of traffic. So drivers have to determine the time of arrival of vehicles coming from both directions, and they turn in the same. So the first solution is to use two radar systems to observe the oncoming vehicles and predict the time of arrival, and then present a warning to the driver. So we have a few existing technologies: vehicle-to-vehicle communication, vehicle-to-infrastructure communication, and then onboard sensor-based collision detection systems. So the benefits of vehicle-to-vehicle communication is that you don't need infrastructure and line of sight, but obviously these are more vulnerable to happen because they have to happen in a very short time and very close range, things like that. So research focuses on developing secure and effective communication protocols. With vehicle-to-infrastructure communication, you have the ability to place various sensors at any point around the intersection, but this comes at a sorry. So vehicle-to-infrastructure communication allows you to place sensors virtually anywhere around the intersection, but the downside is that you have to maintain this infrastructure and it comes at a higher cost. So on-board systems, these don't rely on any other external technology, and also no communications latency. But the disadvantage is that now we have a single restricted viewpoint. So frequency modulated continuous wave radar. This is the type of waveform that's used. It's the waveform frequency changes periodically. And then terms here for this project are time to turn, which is the time required for the host vehicle to merge onto the road, and then the time of arrival of the oncoming vehicles is the TRA. So we're going to talk about some audio selection based on some requirements, and then move on to the waveform design, and then end up with a signal processing algorithm. So the maximum range we require is based on the time to turn. So I assume the time to turn of 3 seconds just to make it easier for the radar. So 3 seconds is the time required to bring onto the road without requiring the approaching vehicle to slow down. And then I use the maximum speed based on the main road of about 70 kilometers per hour. So we only needed lane resolution because we need to separate cars along the lane. We don't need to separate the angle or facing the speed based on the car's length, and then the accuracy was based on GPS accuracy, which is the closest technology that can do such a thing. And then we needed more data, so they developed a custom algorithm processing this data, and then updated actually faster than a human simulation capabilities. So the hardware that was selected was the URA USB, low-cost system, and it came with a Python SDK, so it was simple to develop code for that, for real-time processing as well. But the disadvantage is a very narrow beam, so even at the edge of the beam at about 15 degrees, you can see it really starts dropping quite a lot. So the selected waveform was a triangle W. It consists of an up chirp, so then increasing frequency followed by a decreasing frequency. Here's some basic equations, so converting the Doppler shift to speed, and then getting the range based on the beat frequency of the plot now, and then the gradient of the slope. So we get a time delay between the transmitted signal and the received signal. So the received signal matches the transmitted but delayed time. That gives us a beat frequency, which is the difference between the received and the transmitted frequency. If the child is moving, we get a Doppler shift. That adds, subtracts from this beat frequency and it adds the down chirp beat frequency. Using that property, we can add these two beat frequencies or subtract them to separate out the Doppler component or the range component, and that's how we calculate range and speed using triangle image. Okay, so the spectrum gate algorithm, this uses a gate that starts at the frequency of detection in the one chip, so we get the peak frequency of that chip. We then set up a gate starting at that frequency and increasing up until the maximum expected of the chip, and then we use that to limit the search in the next chip. So that is like this. So we get detection there, we then set up a gate in that up chip or the down chip, and then you apply that to the opposite chip, and then we can see that there's another detection in that gate, so we know those correspond to the same target. And then I have to do some angle correction here because as vehicles are not, the radar image is the radio component and not the actual component of speed. So based on an assumed width of the road, I'm going to use that as a measured range to get the angle of arrival and then apply that to the velocity, measured velocity to get the actual speed. And we'll see now how that works. So after simulating, using firstly the automated driving toolbox in MATLAB, so that allowed for quick and easy simulation of the scene, but it didn't allow for like simulating with the actual processing algorithm. So I had to switch to the phase-based system toolbox, which is a bit more complex to use, but I could add my own processing and test them and see if it's working properly. So the one kind of difficult case was the masking case, which is where the vehicle traveling here comes in front of the host or the left side vehicle, and then you can't see it. So it's similar to you sitting here, you can't really see through this thing. So that's one of the difficult things of this project. So simulation results. I got the left side radar, measure the speed here of this one time with 45 meters per second, 45 kilometers per hour. But with the, as shown in the previous slide, with the vehicle crossing over, we can start detecting it. So normally we can filter this out because we just filter only vehicles coming towards us and not vehicles that are driving away. But that does cause a gap in it. So normally we can use a common filter or some tracking algorithm that knows that the target can't disappear and kind of interpolate that until we get detections again. Similarly, for the range detection, we see the vehicles approaching us, and another one comes across from very close range and starts moving away. We can also filter that out. But this gap will need a tracking algorithm to cover that. Then we have for angle correction, so you can see the blue circles, they start dropping off as the angle of arrival increases. And then with angle correction, you can see that these orange circles don't drop off as much. So these are the roadside test rig loops. So two cameras so that you compare the video data to the regular data. There's an angle adjustment component on the left side, so we have to steer the beam physically to get detection from the left side, so the outer angle of traffic. The real-time processing happens on this pi, and then it streams out the video, or you can stream out raw data. So with the just raw data, we can capture about 92 frames per second. But after adding, so Python processing is a little bit slow, but even with that, it could do about 82 dots per second with multi-threading. And then for the right radar, we get consistent detection for cars coming on a cursor lane. But for the left radar, we obviously had those maximum masking case, and then also we had, since the beam was steered, I steered this at the edge of the beam was at the max range, but since the gain at the edge of the beam was less, we lost our max range on the left side. So for the right side, that's how it looks. We have time going down here, range, and then it's grading kind of by speed. So you can see the speed is between 50 and 60. We get consistent detections, and since this was a narrow road in the street, we picked up some vehicles on the lane moving away, but they don't form like a track because we only fortunately found targets on the positive number. And you will see the next slide for the velocity measurements. When it's like this, there's a clustering around this. Normally we use a clustering algorithm to get the actual velocities of the some targets grid. And then this is the GPS, so you can see within the GPS accuracy, these measurements were within this GPS accuracy. And then the time of arrival calculation, which is based on the speed and the range, that matches the GPS as well. The left side, we had the reduced range there, and then we rate really, so tracking algorithm will help with that. And normally it's brief, unless it's a very high traffic, in which case you probably need to use another way of navigating that. So here the GPS had a slightly less accurate measurement this time, but the radar was still very close. And then here it deals with more, I'll chat about that time. And then you can see the time arrival matches GPS. Finally, we have the uncontrolled results. So right side radar has expected very clean observations. But on the left side, we have a few there and then there is interference. So this can be filtered out based on, you can't have a target in the same range, but moving at 70 kilometers per hour. So you know there's interference and you can filter that out quite easily. So thanks, I have some extra time, so I'll just mention how the equal works. It's in a chip using a multi-control oscillator. That gets the transmitted chip gets mixed with this mixer, and then you get the picture. I think this is just familiar side.
Thank you very much.
Okay, thanks.
Questions?
Thank you for your talk. So what type of advice do you give to the user or car driver coming out of the system? I mean, you can see cars approaching, but you know, I also want to have like.
So I would do something like, so how it represented would be like this, okay? So it would be like a visual and then also like a audio type of board. So this would probably go yellow and go red as this thing gets more dangerous. So this system here just kind of shows you there's a hazard there, but it doesn't predict if I turn later on I need this guy to slow down. Otherwise it's going to be, So it will be similar to this.
But this also highly depends on the capabilities of the driver, right?
Yes, and as usual. Yeah. Yes.
In cases just like that you have a very close crossing, right? You have low visibility. Have you considered the implication that you have to switch the places of the radars, so like the left one is looking right and vice versa? Because in that case, for instance, the right radar looking left would have more time to see the car, the incoming car, than the left.
I'm not sure what you mean. Do you mean if this
If you switch the positions of the...
They both look up the same, they share the same...
They look to their side, but if they were looking across
each other?
Yeah, if you cross it out, you would see the car coming before you...
I think, you say this here line of sight where this one will be blocked.
Yes.
Well, I think normally when someone drives there, you kind of stick the bumper out a bit, and then this one should always have, so you should stick the bumper out so that because otherwise you can't see anything. And this, I think this is an exaggeration of the scene. I don't think there's any road that's designed with a wall, there's no pavements around the edge here. So,
it shouldn't be, but
this is just, I thought this one makes this website. It's not, I don't think it's the existing.
I mean, in the scenario that it would give you more time to make the decision.
Yeah.
Not in the scenario that.
So I would think, I mean, you could have that, but like the way it mechanically could rotate. But I think it would be best to just park and jump out of it more. So try to stick the bumper out more, would be better to try to get this one to see instead of trying to rotate that. Maybe it's quite difficult with the bumper curves a bit. The radars here, you can't really get it. You know the thumbs up.
Okay, works were done. Now the total presentation papers have been presented. Let me see if the remains. Okay, now we proceed to the next phase, and the next phase is group photo. So I request the participants and all the delegates to proceed to the photogate stage. Thank you very much. All those present only. All those who presented papers. Yeah, please come. You go on, let's go. Yeah, this one. Anyone else who presented? Please join. Thank you.
Yes. Yes.
Cool. Okay, now good. Cool. How do you pronounce your name, your last name?
It's not the certain kid, this is my supervisor.
Oh, okay,
It
okay.
starts with an X. X.
Are you the one presenting?
Yes, I'm the one who's presenting. The last years.
Kamash, okay, Kamash, got it. Thank you. Hello? Are you presenting? Oh. I am chair, yes. Yes, everyone's loading their presentations right now, so. Yeah, it should be good. Should be good. Do I just start? Sure, yeah, I appreciate that, thank you.
I appreciate the help, absolutely. I'm going to use my phone, but if you want to use these two, you can. I'm going to use my phone at time. 12 minutes, 2 minutes for questions.
And then, yeah, obviously, after the session, I think it's nice if you can.
Yeah, take pictures, yeah, after each, yeah. Yes, sir.
Great. Somewhere down here, see if I think of bringing that street down just a little bit more, but it's okay. Because the beautiful project we set up for that. Waste. More space. Yeah.
Going to my diagram, maybe. Yeah, I figure whenever I go up, I can just copy it over. Try to make it very seamless. Thank you. I appreciate that.
No, they sent us. Yeah, but it's
Okay, good morning, everyone. My name is Mike Davis. I'll be the session chair. Quick little, what we're going to do, we're going to go through, I think, 7 presentations. You've got 12 minutes, and then 2 minutes of questions. If you finish early, that's totally fine. So I'll call out name, paper of who's going, handle your stuff, and then we'll take a photo with your certificate, and then move to the next presentation. So any questions before we get started? All right, so first up is Raghu. An in-depth scientific analysis of rooftop solar PV power potential to facilitate strategic deployment and implementation in Mauritius. And it looks like he stepped out. Are you ready? We're ready for you. Already introduced your papers. All right, without further ado, start whenever you're ready. You got 12 minutes.
Hello, good morning, everybody. I'm Raghu from Mauritius. Today I will present my research overview, which is about an in-depth scientific analysis of rooftop solar PV power potential to facilitate deployment and implementation in the island project. So we have a population of around 1.2 million people, and the growth from 2016 is around 1%. However, you have an estimate of growth of energy requirement about 20%. Here you have the energy situation. We produce 41.9% of our needs of electrical energy in coal, 35.6% in petroleum, bagasse accounts for 11.7%, hydrogen 3.6%, weight 0.5%, landfill 0.6%, and photovoltaic 5.1%. Approximately 80%, that is 2,280 gigawatt of electricity, is generated using fossil fuel. The petroleum imports from Middle East is estimated around 800 million rupees. It depends of remote countries, and this becomes our economic stability. The fluctuation of oil prices on the international market bears economic repercussion on the island. Our aim, as per our strategic plan, is to reach 40% of our needs of energy using photovoltaic systems by 2025. As you can see, the graph of the curve, this, if you look at the curve below, we can see that we have already crossed the half-line limit of our fossil fuel reserve. That is, we are left only for around 150 years of fossil fuel to plug the end of the petrol era. Compare this with the lifetime of the sun, which is around 5 billion years, we have here also reached halfway. So clearly, the future of producing electricity is the sun. The emission of the energy sector, coal and petroleum, blame for contributing 61.6% of the total CO2 emission on the planet. For small island developing states like Mauritius, the aim is to shift the dependence on alternative that is less polluting and more reliable energy sources. So the government vision, our long-term vision is to achieve 60% of renewable energy in the electricity mix by 2030. The solar energy focus, solar PV technologies are among the most lowest cost technologies available. The rationale of the study is as follows. The findings of the study are expected to provide a valuable insight for policymakers, energy partners, engineers, architects, investors, as well as researchers and practitioners in the field of solar energy. This paper can help to identify the most suitable location for solar energy systems and to optimize the design and operation of these systems. So the solar potential of Mauritius. The maximum solar radiation tends to occur in the northern and western region. It's approximately around 70 megajoule per square day, as indicated here in the northwestern part. The minimum solar radiation tends to occur in the southern part, that is approximately 50 megajoule per square per day. The southeast trade wind blows from most warm air from the ocean, as you can see. As the air is forced to rise from the central plateau, condensation occurs. The clouds from the lower central plateau reduce the amount of solar radiation, and this brings us to the strip of the most concentrated air in the north and west. That is why we are concentrating our studies in the red or red region, which is the most appropriate because of the ability of high solar radiation. Rooftop PV systems. The array type describes whether the PV module in the array are fixed or whether they need to track the movement of the sun across the sky with one or two axes of rotation. In this study, for the case of Mauritius, we are planning fixed rooftops as our buildings are mostly flat and can accommodate these panels, unlikely like, for example, in the UK, where most of the roofs are inclined, so there the study will be different. A fixed side, approximately 20 degrees south, because we are located in the southern hemisphere, and our altitude is approximately 20 degrees. That is why we have a tilt of 20 degrees, which is the most effective. However, the location of the rooftop PV potential in Mauritius will dictate its overall yield. Now, the method. The method we have, first of all, the house rooftops of the region of high solar radiation are digitalized. Then the rooftop area is calculated. The available rooftop targets unshaded and only prepare the rooftop where solar tanks, other like solar heaters or other shading has been considered, where the available rooftop area. First you calculate the rooftop, then available rooftop area, where we feed on the equation you have in front of you. We will calculate the electric generator using G stands for global horizontal gradients, efficiency of the panel, multiplied by available row. So the feasibilities exploited rooftop values are summarized to reveal the potential for a given region, the available area, the electricity generation, the share of electricity demand, and the policy implication. So I will come back quickly to not waste further time on the results. So here we have the whole island. We are going to display the results of a city called Woodlands, where we have the highest evaluation, and secondly for a district called Williams. So the yearly mean daily Williams values vary from maximum of 4.84 kilowatt-hour per square day to a minimum of 4.21 kilowatt-hour meter square per day. The north region of the plain of the island benefit for the highest intensity of solar radiation throughout the year. The city of Woodlands in the north, as you can see the white part, the city of Woodlands in the north of the island has the highest solar potential than the Pennsylvania region. So the results we have been able to conclude are as follows. This we have the city of Woodlands. Here, the installation of rooftop PV in the city of Woodlands has the potential to generate about 3.6% of the electricity demand of the country because of its high solar brightness. Consequently, the deployment of rooftop in the PV city of Woodlands would be able to generate around 109.4 kilowatts of electricity and converge to the equivalent of 68,375 tons of carbon dioxide emissions per annum. Besides battery pump or additional hydrogen-based storage can contribute in dealing with peak load demand. The surface energy chlorine generated during the daytime by the rooftop PV system to pump water into a reservoir where demand is low and store it for the subsequent electricity generation during night where the demand is high. Here we have displayed the results for the whole district, which accounts, as you can see, the last term, around 57.7% of the needs of our needs of electricity demand. And if we extrapolate this to the whole island, we can see using the rooftop, we can produce 207% of our needs. So being a small island where we have the land exclusively, we can reserve the land exclusively for agricultural purpose. We don't need to waste or to do deforestation to be able to generate electricity using PV plants. So the results of our conclusion by itself, we have found a high level of insulation coupled with a high population density of the region of Woodlands, situated in the northern region of the island, favor the site as being the best zone for large-scale rooftop deployment. Secondly, the result shows the deployment at city scale to provide 3.6% of the electricity demand at the national level. And finally, the results presented in this paper provides a roadmap for achieving strategic and sustainable investment for maximum on solar potential while reducing the country's dependence on fossil fuel. So thank you for your attention, and I welcome any questions from the audience.
I've got two. The first one, so your rooftop analysis, you said you eliminated all obstructions. Did you consider like water tanks and such? Did you consider incorporating them?
We have considered all the obstruction like water tanks, solar meters, shadings, but account to a factor of 0.26 only on the rooftop. In the equation, you can see the area multiplied by 0.26. So how we have done this? We have done a survey of 50 households where we have reached to the value of 0.26.
Including the tanks or not including the tanks?
No, including the tanks, yes.
I would only suggest you could maybe allocate like 20% of rooftop space to unavailables to make your model a little more conservative.
Yeah,
it's good. I've been in Mauritius. It's a nice country.
That's a great suggestion that we're taking on board. Based on our survey, our regional logistics, which is what nearly 20%.
Yeah, that's good. What module size did you use for your calculations?
Sorry?
What wattage and modules did you assume for your calculations? Like 550 watt or the size of your panels?
Yeah.
Okay, cool. No, that's good.
Any further question? No. Thank you very much.
All right, thank you. Thank you. All right. The second presenter, Rockefeller, wind power prediction with HCNNs for turbines. Okay, so, hi. Hey, Kevin, whenever you're ready. So, good morning, everyone. So, my name is Rockefeller. Good morning, everyone. My name is Rockefeller. I'll be presenting on wind power prediction with estimates for turbines. So, I'm currently a PhD candidate at South Africa, and this work is supervised by Dr. Wakaba and Prof. Maribati and Dr. Hans Gertman from the Vancouver Society. So, this presentation is about wind power prediction. And the final goal of this research is analysis of climate products with the use of a frame of neural network called historically consistent neural network, or HCNN. And what we've done so far is basically wind power prediction. And one may ask, why wind power prediction? Well, we are living in a world where traditional sources of energies are in decline, and we therefore need to resort to new sources of energy or to optimally exploit our new sources of energy. And therefore, the provision of wind power forecast is basically important for operations on wind turbines. If you think of short-term grid stability, when it comes to, for instance, balancing demand and supply and demand in terms of energy, knowing how much wind power, how much energy will be available in the near future can be very helpful for operations on grids. And also, we think of long-term power generation serve the purpose of planning, where, for instance, governments and energy companies can actually design a strategic plan when it comes to, let's say, plan for infrastructure upgrades or maintenance of existing ones. And the mathematical structures of HCNN models, historically consistent neural network, is suitable for this type of exercise because it's able to model complex systems. And so far, HNNs, which were designed by my collaborator, Dr. Hans Gertman, were successfully applied in financial environments. But this is the first time ever that this model has been applied for the modeling of wind dynamics. But why HCNN? Well, because HCNNs are suitable models because they capture the causal relationship between variables of interest and also provide a construction of unobserved variables. I'll explain about that in a minute. But first of all, let's see a bit how RNNs model dynamical systems. When it comes to dynamical systems, sometimes we are not aware of the total amount of variables that drive the systems. But fortunately, we can measure a few of them. And those models we measure comes in sequential formats or sometimes time series. And RNN basically uses text-based formulation that you see on the top left in order to model dynamical systems. They assume a linear relationship between two transitional states, and the outputs of the system is simply linear transformation of the systems. And sorry, I need to move to slide one just so that not happen. Anyone has an idea how to move to slide presentation? Do you need to move it down?
It's pretty difficult.
Yeah.
So, and looking at the architecture that you see down here, we can see that the complicated dynamics actually exhibited by the systems is basically described by Icecet by CNR and using two components, autonomous dynamical systems, autonomous dynamics, and external general systems. And but the point is, when you look at this architecture, looking at the past modeling, we can see that RNN use external signals in order to strengthen the autonomous system and deliver outputs. But on the future modeling, those variables are not available, which create what we call the temporal inconsistency that you see here, the unavailability of external signals in the future. And that's exactly what HCNN is trying to resolve. Well, resolving such problems comes with basically reframing the way we think, the way we see the world. You know, measuring the dynamical system, we are only able to see a fragment of the world. In order to model dynamics of interest, the assumptions we have to stand is that we have to reconstruct at least part of the hidden variables of the world, if not all of them. And that's basically what HCN is doing, and model all of them in the same manner. And looking at the architecture, we can see now we have a consistent architecture both in the past and in the future, without some inconsistency. But in practice, HCNNs are very hard to train because they're not making use of external signals. Therefore, we make use of architectural teacher forcing in order to account for that. How does it work? It basically works by replacing the output layer by a cluster that is giving a target value equal to 0, where at each time point the difference between expectation and observation is computed before being reflected to the system. This is to avoid propagating accumulating error throughout the training or throughout the learning period. And we've also designed improvement methods to actually improve on vanilla HCNN that you see on the screen here. One of them is called partial teacher forcing, and we basically train those models together with two other improvement methods and publish them in a paper that technical results can be found here. We basically refers to fully orthogonal systems, like Lorentz systems, and be able to model the dynamics on a very long run. But now, using those insights, we transition to partially orthogonal systems, and wind data is one of them, because we can't have a full description of how the wind dynamic works, but you can actually measure some of the variables that drive that system. And we received data from the Wind Atlas South African project, the WASA project, which includes more than 19 wind measurement masts all across the country, that you can see on the map here. And the temporal coverage of the data dates back to 2010, and the temporal resolution is over 10 minutes interval. So many variables were provided, including the velocity of the wind, direction of the wind, which we are trying also to provide in this focus exercise. But before we do so, we need to choose carefully the time space selection in terms of what is the time grid we want to use in order to prepare our model. And looking at the variables, since our concern was also about providing focus of the direction of the wind, we basically had to do a transformation from polar coordinates to Cartesian coordinates. Okay. So, talking about that, if you think of the original HCN approach that we developed earlier, we use a fully unfolding, which means for the fully observable systems, the whole time series was deployed at once, which means the architecture of the whole network was placed into the whole time series before the modeling. But this is not practical for engineering application because we can't use the whole distribution of time series data from the wind in order to provide a focus. Therefore, we have to change the mode of training. We use what we call the average mode, which means we choose only a fixed interval that will displace, we shift around different parts of the whole time series during training time before providing the focus. And our focus that we're given in form of two different modes. We have a short-term focus where we use the time of 10 minutes and provide a 24 times the focus in the future. We also have the long-term mode, so we provide on a 1 hour basis, 24-hour focus. And this table was actually to be filmed. But remember, I talked about having direction and velocity of the wind, which is not practical for training a model. Why? Because of the singularity that the angle or direction of the wind shows around 0 to 60 degrees. Therefore, we need to provide a transformation. So we basically transform wind speed direction into wind vector using this formula here, where the velocity of the wind is represented by v and the angle is represented by phi. So we now have the wind vectors, which have two components. Those are the variables that we are going to focus. But before doing so, for the post-processing, we have to transform it back to wind speed and wind angle. And to avoid breaking the assumption of temporal inconsistency, we also make use of variables that we know are available both in the past and the future. We might not know how much wind will be available tomorrow, but for sure we know that tomorrow will have 24 hours. Therefore, the time index at which data was sampled from was used as external variables because they are both available in the past and in the future. These are supposed to have led us to a modification of the architecture that you see on the down here, where we have external variables now, and a modification of also the temporal equations as well. Now, looking at the results, we basically present or we have the results in form of low wind speed regime and also high wind speed regime. What you see on the screen here are observations which we true data against our HTML models. You can see that on the short-term forecast, which is 24 time step on 10 minutes, our model is able to reconstruct to its best the curve of the true data. And on the right, we have the 24-hour forecast representing the long term for this problem. Coupling our models together with LSTM and RNN, for instance, we have another display of all the models together, and it's very difficult to appreciate everything from here, but looking at the summary table later on, we'll see that our model was able to outperform all of them.
You have 1 minute.
Thank you. And here this is high wind speeds, and the same observation can also be made here for our forecast. Good. Now looking at the summary table, we can see that the HTML with positive forcing, which is our method, was able to outperform RNN and LSTM by a factor of 3 on the short term, and literally by a factor of 10 on the long term here. Now, the next one we talk is about our work, is basically about generalizing our results on space and time, because we know the physics is the same across the different locations in the country. Then we want to see if we can use our model, if our results are applicable across various locations in South Africa, and also how long we can reuse our model before going back to the training. Those are the two questions we are currently busy solving. And that's basically it. And thank you for your listening.
Awesome. Any questions? All right. Good job. Okay. Our third speaker, Wasira, dual gradient maximum power point tracking method for solar panels. Are you ready?
Thank you. My name is Joseph. I'm going to be presenting to you our work we've done together with the other 3 others. It's titled Dual Gradient Maximum Power Point Tracking for solar panels. And I think I'm also going to suffer the same cost of not being able to see the slides evenly, but fine. This is what I'm going to discuss in short. I'm just going to give a quick introduction as to why we need maximum power point tracking techniques, and also give an overview of the large model of a PV cell, then discuss the concept of MPPT, then give an example of one classical method called Patagon itself, thereafter discuss the methodology and give results. So we know that PV converts solar energy into electrical energy. By now we have seen that, and we are able to capture probably 30% of the already available solar radiation by the solar panel. But out of the 30% that we get, how do you ensure that we have the 100%? 100% of that. So therefore, that is a technique called MPPT, for short, maximum power point tracking, which increases the efficiency of the solar panel. And for this, there is a mathematical model that represents the relationship between the current obtained by the solar and the one that is from the irradiation. And this here represents the relationship where we see that the cell current has a relationship with the current from the radiation. And there shows some the circuit for an ideal PV cell. Next, as we've seen, is that there is always a relationship between power generated and the current generated by the PV cell. And therefore, that is always given in terms of IV PV characteristics. And one thing that I want you to concentrate on there is that point where we call the maximum power. We always need to track that point at all times at different operating conditions. So therefore, that requires us to have the techniques that we just said, the MPPT techniques. And two conditions that are very important in determining the MPP is the irradiance and temperature. Because we know that as temperature increases, the power reduces. But irradiance increases and the power increases, as can be seen from those two plots there, where we have one of them on the left, temperature is constant, and on the right, irradiance G is constant. An MPPT is simply an electronic system that operates the PV modules. It helps it extract maximum power from itself. And this MPP point is just a specific point for any given temperature and irradiance combination. And we always need to track that point, because if we leave it to itself, it might not be able to track as much as we would have wanted it to be. And this diagram here just gives a general setup of the MPP system together with a PV panel. And in MPPT techniques, there are different classifications. There is conventional methods, and there is also intelligent methods. In this case, I've just identified the pattern and observed as one of the conventional methods, and also the artificial neural network is an intelligent method for identifying the specific MPP point. So normally what we observe uses this flowchart diagram here, and you see it measures the voltage and the current at a given time step. But what it does is, if the power or the voltage is on the power is on the left-hand side of this curve that we have here, then it needs to increase the voltage. But if it's on the other side, it needs to reduce the voltage until we get to this point here, which is the MPP point. That is where we want to operate for each and every operating point. That is for temperature and irradiance pair. Normally, MPPT techniques like pattern and observe operates together with a PID controller that just used to correct its errors. And this is just the normal operating of a PID controller here, where you need to tune KB, KI, and KB. But one of the challenges in PID controller is that you have to find those KB, KI, and KB, which is not an easy task, especially for linear systems, which we have in our case of a solar cell. So, what are we proposing here? We are proposing to use ANN to predict the MPP point given temperature and irradiance, and using a gradient-based method to perturb the duty cycle in order for us to have the solar panel operating at its peak, that is at MPP at all conditions. So you can see what are the inputs, what are the outputs of the neural network. It's power and current. Power and current have a good relationship with the irradiance. They normally tend to have a linear relationship. That is, as irradiance increases, power increases. So it becomes a very easy task to create a neural network. And this is the structure of a neural network. Just use 10 neurons in the hidden layer and two for the input and output respectively. Thereafter, use the power law to get the voltage that we want to find, the voltage at MPP, which we are going to be tracking. Those are some of the results that were obtained after training the neural network using the MATLAB and minimizing the mean squared error. So normally, in gradient descent, we know that we need to find the cost function and find the derivative of the cost function with respect to the parameter in which you want to optimize. In this case, we know that we want to reduce the error between the operating voltage of the PV panel and the MPP voltage, which is therefore gives us the error. And what we're minimizing is this error, which is normally referred to as MIT rule, which is commonly used in model predictive control, where you have a model of the system that you want to be able to control. And the whole of this process is just for us to be able to identify the DJ and the DD. Therefore, we would use the gradient descent to perturb the duty cycle in the direction that minimizes the error or the cost function in this case. And you can see that DJ and DD is capped or clipped between 1 and -1. In this case, delta could be a value between 1 and 0. Because we know that duty cycle is a value between 0 and 1. So you don't want to perturb it too much. If you perturb it too much, you're going to have saturation. And your value will always be 1, 1, 1, 1, which is not the true representation of what we want. The results that we're going to present here were given for randomly selected pairs of irradiance and temperature without following any rule. And what you can see is that the proposed system in blue, we're going to keep track of two components of control. One of them is speed, how fast does it respond to change, and two is the state error. How much oscillation or how much difference is it around the non-set point. And this can be seen from this power here, that our system was able to respond quickly to changes in radiance and to changes in power, and also oscillate less on the right-hand side. You can see the zoomed version, where you see that the blue is oscillating around the maximum power point, which was predicted by the neural network from the beginning. And the same phenomenon is experienced with voltage and current. One other way to measure how well your system is working is use of efficiency, where efficiency is the sum of the power obtained from the solar panel over the total expected power from the solar panel. And what we saw is that compared to perturb and observe, a classical algorithm that is widely used is that our algorithm was able to have an almost a 7% jump or addition to power nest. And in conclusion, what we have seen is that we have introduced a neural gradient method that combines neural network with gradient descent to be able to track the maximum power point of any given power MPP, which is generated by irradiance and temperature. And what you have seen is that our method has a fast rise and a minimal steady-state error, and thereby having a huge efficiency of 97.46 compared to its counterpart perturb and observe, which was used as the base algorithm in this case. But despite all this, these results need to be tested experimentally, as this is a MATLAB simulation. It can be disclosed, but you also need to go to the real setup because things shift and you don't want to see what happens in the real world. Thank you very much, and if you have a question, please feel free to ask.
Any questions? Oh, yes, sir.
So you mentioned duty cycle. Can you just explain clearly what duty cycle you're referring to? Is it on-off of the solar panel?
Is a duty cycle of converter in use, because if you use a buck converter, for example, in this case we use a buck converter, right? So that we can be able to push the power out of the solar panel. So it's just going to be operating as an on-off thing. There's a MOSFET actually. It's a MOSFET kind of requires a duty cycle, which is a value between 0 and 1.
Any other questions?
Is it intended to be a retrained system, or is it intended to learn as it goes?
It's a pre-trained system, but the gradient itself is going to be learning as it works, right? It's going to be adapting as it works. The error is going to be reducing as it works. So it's continuous, yeah. But the neural network is pre-trained because you want to have a fixed set of MPP before you can use the gradient descent.
All right, thank you very much. Good job. All right, next up is Rootman. Optimal placement of a voltage regulator on a medium voltage network. whenever you're ready.
It's working. Good morning, ladies and gentlemen. My name is Owens Rutman. I'm a student at the University of South Africa. Today I'll be presenting to you about optimal placement of a voltage regulator on a medium voltage network. Sub-element, low-contained bulk voltage regulator. This project has its origin in a small town called Bloemhof in the northeast province of South Africa. The main inhabitants of this town is mainly agricultural farmers, farming various crops. And as a result, they are irrigating these crops using water from the Vaal River and the Bloemhof Dam. And to transport this water over vast distance of irrigation networking system, they make use of large pumps, motors, and so forth. Being in South Africa, the main utility supplier is Eskom. And the portion of these customers are complaining about voltage fluctuations at the respective points of supply. More specific is that they are complaining about under voltage experience at their points of supply. So to formulate a problem description and to understand what we are dealing with, can have a look at voltage fluctuations as we were beginning the introduction of what that is. So voltage fluctuations can be divided in sub-meanings of under voltage and over voltage. Under voltage, whereby a decrease in RMS basic voltage of up to 90% for a sustained period of minimum period of 1 minute. So that's not just the short term. And then the same with over voltage, whereby it's an increase beyond a minimum voltage of 110%. So it's not just an instantaneous spike, it's at least for a period of 1 minute. Now with modern electrical equipment, being voltage sensitive, exceeding these voltage limits has got severe effects on them. More specific towards this project, if we look at induction motors, low voltages on induction motors causes a reduction in the starting torque and increased flow current. High voltage causes increased torque and increased starting current. All in all, these factors contribute to premature failure of the induction motors, and it shortens the lifespan thereof. Other ones that we can look at is incandescent light lamps, fluorescent lamps, which also are affected by under and over voltage in their different ways. And then ultimately, voltage fluctuations, a volt drop causes an increase in the current drawn by motors. This higher than necessary current must be transmitted to the system, and then there's increasing system losses. Now, if you look at under voltage, give a few examples. It's not limited to, but just to give a brief example of that. So, under voltage is caused by a urban location removed from the power source, long distance from the distribution transformer with interposed loads, unreliable grid systems, switching of heavy loads, and then overloading distribution network. Over voltage, on the other hand, is caused by system faults, disconnection of heavy industrial loads, energizing of capacitor drains, starting load reduction, and then our big friend lighting. Voltage fluctuations. So voltage fluctuations does not only affect the customer, it also affects the utility provider, in the sense that the production cost goes up, the more the losses experienced. So voltage fluctuations can cause technical losses in the electrical delivery network. Voltage fluctuations affects the magnitude of current flowing in the conductor, generating heat and affecting resistance, causing electrical or electricity loss. You can see 6 to 8% of electricity generation cost, up to 25% of electricity delivery cost, and whereby a 10% voltage increase results in a 21% revenue increase. Voltage fluctuations, how can we deal with voltage fluctuations? There's several options on the market. I've listed a few, which is obviously not limited to, but transformers with tap changers, on-load and off-load tap changers, static arc compensators, that's your shunt capacitors, increasing conductor size, automatic voltage regulator, step voltage regulator, and then strengthening of substations. So a literature review has been done on these methods, and I've opted to go with the automatic voltage regulator. So voltage regulator in essence, it is a line device, so automatic line device, that maintains a constant voltage output. And like it detects, it automatically detects a drop and or an increase in supply voltage, and then it automatically makes the necessary adjustments so as to keep the regulation between specified elements. A voltage regulator, how it operates, it is basically a step up, step down auto transformer. That's the basic operation of it, with the different websites got the lower and the high switch in it. And then on the secondary one, that is tapped into different tap positions that allows for different outputs depending on the tap that it's set on. And yeah, so that's basically the basic operation of a voltage regulator. Now, depending on your project specific needs, a voltage regulator can be configured in a couple of ways. If you were to configure two single-phase voltage regulators in an open delta configuration, you can yield a 10% regulation that you can obtain. If you were to configure it in three single-phase voltage regulators in a closed delta configuration, you can get 15% regulation, depending on the amount that you require. Now, in selecting the voltage regulator rating, there's just two main parameters that you should keep in mind. That's the rated voltage and the rated current. The rating of the regulator in terms of the rated voltage must be equal to or higher of that of the system. Then the rated current must be equal to or higher than the maximum load current at the specific location of installation of the regulator. Then why voltage regulator? So, like I said, there's a few advantages of the voltage regulator, of which I've listed a few, but not limited to. First of all, you must know that the voltage regulator is a good short to medium-term solution. It is not a long-term solution. It provides a proper range of regulation. The cost is relatively low compared to other solutions. But in this case, the cost is not such a major factor as the regulation, the amount of regulation required is of more importance. The relocation of the voltage regulator is quite easy and uncomplicated. It's got a positive, the value add of adding a voltage regulator will have a positive financial impact for both the consumer and the utility provider. And then it allows for future load to be added to the network. To give you more on the network technical specifications of this project specifically, the customers are fed from Bloemfontein 882211 substation. It's consisting of two 10 MVA transformers, the one feeding 4 11 kV feeders, the other one feeding 4 22 kV feeders. And then it's on this specific 12-volt feeder that is interconnected by 9.3 kilometers, consisting of big conductor, the backbone. And on this conductor, the key of the customer's complaint is KKB, that stands for Bloemfontein 12-volt 76 kV. It's a total length of 7.3 kilometers and consisting of 19 RPU customers with loads ranging between 100 kVA and 1000 kVA. The proposed installation of the voltage regulators to be installed on KKP 76/3. To give you the geographical location, the area highlighted is the customers affected by under voltage. As you can see, it's close to the Bloemhof Dam, where they are pumping the water from. This is a load profile that was gathered from the statistical meter at the substation on the 12-volt feeder itself, indicating the load profile on that feeder for the period of 2 years, the 2 years of 2020 and 2021. And this is essential for obviously selecting your voltage regulator rating. If you need to know the load, the maximum load current that will flow there. And based on the predictions and I've simulated the current. This is the current network condition. You can see I pointed out 3 of the customers' points and then level of voltage, I think, different levels of voltage. And you can see it is between 0.92 and 0.96 PU that they are currently experiencing, which is well under 100%. And then I've introduced the voltage regulator and performed the simulation, and you can see that the addition of the voltage regulator will increase the customer's voltage levels to a substantial amount. The future study for this project will involve the optimal placement of this regulator, of a voltage regulator on a specific network, in which the following considerations will be looked at: the best compromise between the customer closest and furthest from the regulator, the input voltage to the regulator, confirmation of the on-the-pack change at the energy source, load forecast, motor starting, small-scale embedded generation on the network, and then placement factors affecting the voltage regulator rating. In conclusion, what has been dealt with in this presentation, voltage fluctuations, technical and financial implications thereof, ways to address the voltage fluctuations, introducing a voltage regulator, and discussing the advantages thereof, background of the project network specifics, simulation of the voltage regulator on a specific complex feeder, and then the future study. And then I thank you, and I welcome any questions. Thank you.
Any questions? No? All right. Thank you. All right, next up is myself. So, everybody hear me all right? Yeah. All right, my name is Mike Davis. I'm from Texas in the United States. We're going to be talking about wind turbines today. We have a design that we have patented that we've been doing some testing on. We've got some funding, both private and federal. We've got about $400,000 in funding so far. We built a prototype, and we did some testing on it. And we're going to talk about some of the testing values that we got. So this is effects of blade pitch on the power generation of a novel 3D printed cascaded wind turbine. So our outline, so we'll go through the introduction, we'll talk about the system components, we'll talk about the system performance configurations and testing, results analysis and discussion, and then our conclusion. So to start off, my personal experience, I work as a project manager. I build wind farms and I build solar farms in the United States. To date, I've built 1.1 gigawatts of solar or wind power. Most of my experience is wind, but I've got a pretty good, we're building a 482 megawatt solar project in Texas right now to power 135,000 homes. So that's what I do. Direct experience, land is a very finite resource. The really good land used for building power plants has become very, very rare. So now, like all of our projects we're building in now, the ground is horrible. Not flat, so you have to do a lot of work to it, which costs millions of dollars. You gotta engineer very specific, very special situations for addressing the land that you're building. So our solar project, it's on 3,000 acres of land, 482 megawatts of AC power. Our substation is huge. We have two very massive main power transformers. The substation is too small for the amount of power that the plant's putting out. So that's an interesting problem that we're dealing with right now. That we were stuck in engineering for 3 months on that. It's horrible. So back to wind turbines. So renewable energy projects being constructed in increasingly challenging locations. Locations with desirable attributes such as wind or solar resource power, availability, flatness, soil composition, water retention, and drainage are becoming rarer. We built a solar project in a rice field. It started raining in the rainy months. The whole project submerged in water. So no one could work for like 3 months. People don't, it's getting ridiculous. So for project sites with relatively low wind resource power, it's desirable to increase the potential electric power production capabilities of wind turbine assets installed at these locations. So since 1998, wind turbine capacity, rotor diameter, and hub height parameters have all increased significantly. So since 1998, so the average onshore nameplate capacity is up 319%, average rotor diameter is up 164%, and average hub height up 66%. So we're building taller, right? Because you want to make more power, you got to increase the size of the disc, the rotor, so there your blades are moving, right? So you got to put it higher, faster wind speeds, you got to make it bigger to capture more air. So rotor diameter and hub height, there are only two of several factors impacting project level capacity factors. So you can kind of see the trend line there for hub height in blue and rotor diameter in green throughout the years. Wind turbines deployed at the project sites have lower wind speeds in 2021 than in the previous 7 years. So indicating that land that's really windy, good for wind turbines, is becoming very rare, right? So we have to start making concessions about where we can build, because we want to build wind turbines and make wind power, but the sites aren't as good as they used to be. So wind power plants that came online in 2021 are, on average, located at sites with estimated long-term average 100-meter wind speeds of 8 meters per second. The lowest average wind speeds in the last 8 years. So current industry data on projects defined as under construction, in advanced development, or pending, are proposed, indicate that wind projects over the next several years will have, on average, even lower long-term average wind speeds. So some potential explanations, including lack of available sites with higher wind resources, availability of low wind speed turbines, featuring lower specific power, enabling economic build-out of lower wind speed sites. So technology is getting better. We can do more with less wind speed, so people are capitalizing on that. And then transmission constraints. So some of these sites are very remote. The economic hurdles of being able to interconnect that power to the grid is, it's very expensive. You have to build a substation, build a transmission line to the nearest switch yard, interconnect it to the switch yard, and if it's far away, it's a big process, so very expensive. So this is a chart summarizing basically what I just talked about. So you can see the trend line for wind speed kind of decreasing throughout the years, and then we've got an estimation for the future for these various projects that I talked about, and the wind speeds are even lower. So this is a wind turbine that we designed and built. It's got two independently functioning rotors. They use telescopic shafts so that they have no interference. If you spin one rotor, the other rotor doesn't move unless you spin it itself. Each is connected to its own generator. I wish I had a pointer. Actually, I might have. There we go. This is a generator, and this is a generator. So this generator is connected to this, which is the back set of blades, and this generator is connected to this, which is the front set of blades. So in theory, we're approaching the constructible limits of how big we can make some of these turbines, right? Because we only have, we can only transport things that are so large. And, GE now makes wind turbine blades that are in multiple pieces. So things are getting too big. So instead of making this disc bigger, we're going to create another disc right behind it to capture additional power that the first disc isn't capturing. So these are some specs. So the hub height is 1.9 meters. Blade length 79.2 centimeters, width 3.8 centimeters. Output per rotor is about 5 watts. The device is about 8.8 watts total. Because we measure the outputs of both generators independently. It's made out of ABS. We 3D printed almost all of it. The gearbox is planetary, 5.25 to 1 ratio. Generators. It's got 12 coils, 475 wraps. Wire type 34 gauge copper. We made them ourselves. This is a control turbine we built with only one rotor, exact same type of materials and configuration to try to keep part similarity as close as possible. So this is a single generator, so we tested both of them and we compare the results against each other to see the power gains that we got. They've got servos in them for each of the blades, so the blades can rotate. So the purpose of this research is we tested each turbine at varying blade pitches to see what it does to the system, and we got some very interesting results. So this is the full prototype with both rotors. In this test, we've got an anemometer there to measure wind speed. That's our little Arduino Uno. Right there, we've got everything connected to. This is how we wire things up. We've got Hall effect sensors to measure the RPM with rotor shafts. To speed things up a little bit. And this is how we're wiring up the prototype. That's got the 2 generators to them. It's also got Hall effect sensors on each rotor shaft. This is the Arduino board. We've got an SD card, so it saves everything to CSV on there. Cool little video because it's very hard for people to conceptualize what's going on. Wow. Cool. All right. Well, I can't play the codec, so that's sad. Can't install the codec, so that's sad. All right. Moving on.
You open it with the browser, the web browser. Most like the web browser stuff.
It takes so much time to do those, you know. Sometimes it plays, sometimes it doesn't. It does. It's not connected. VLC. Oh yeah. You never go wrong with VLC, right? Come on. There it is. So this is it working, right? So you can see, so the rear rotor doesn't perform quite as well, obviously, because it's encountering less air. So you can see that the front rotor overtakes it every so many revolutions, right? You can see these LEDs down there. One is connected to each rotor, so that's the front rotor and that's the back rotor. So you can see they're both receiving power, and that's it rotating. You see the generators, each of those moving. So the gearbox is the white, and the purple is the actual generator. Bolted them together, so this is it functioning. Kind of helps put the picture together when we're talking about it. All right, we're gonna go a little bit faster here. Whoa. All right, so these are all the tests we did. These are the controls. This is the blade pitch angles for each, the average power output, average RPM, and the average wind speed measured. And this is what we did for the prototype. So the red, all the values are 0 because the angle of attack is either 0 or at 90. So there's no lift being generated. So we just didn't include those in our plots. But this is what we were seeing. Some of these have crazy power gain. So this is the data plotted, where we've got the front rotor of the prototype is the purple line. Obviously, you see it perform really well. The red is the rear rotor. The green is the control, the single rotor, right? So it's kind of in the middle. Throughout these tests, we were able to deduce that there was some very interesting constructive interference occurring, that when both rotors were acting together, the system performed better, which is interesting, right? Like, we definitely need to do some more research on this, but it's something I predicted when I wrote my thesis a couple years ago, but it's interesting to kind of see it coming out in the data. So yeah, this is just plotting. So this is a summation. So this is a screenshot just showing the blade orientation. So whenever there's 0 degrees offset from each other, so they're basically like right over each other. So the front rotor is seeing all the fresh air. And then when they're 22.5 degrees offset, 45 degree offset, and about 75 degrees offset, kind of just what they look like. So this is the results we got. So you can see it kind of varies. We got 55%, 93%, 21%, 121%, 128%, which is kind of ridiculous. So this 81% is pretty consistent with the other prototypes we built. We started off with like a really small one and kind of scaled up. So the 81% is kind of more in line with what we've been seeing with our other prototypes, and then this one, and then this one's just absurd. So I left it in there, but it's like an unbelievable value. So I would say that this one is more in line with what we've been seeing with our other size prototypes. It varies anywhere between 78% and 84% power. So this is probably the most valuable data point, the most realistic, right? So just to talk about our future works. So the biggest thing that we took away from this is that the angle of attack, obviously varying it, affects the performance of the other rotor drastically. So we did it where we did different angles for the front and then different angles for the back to kind of see, and the more aggressive the pitch angle on the front was, the better the back rotor did, which was interesting. That's how we got some of these really crazy results. So currently we're building a 4-meter tall one out of metal. It's a funding we just got, and we're going to be looking at the airflow interactions between the two rotors. So that's what's next for us. Right, yeah, so that's all I got. Any questions? Yes, sir.
How do you choose the location where to deploy those?
So that's a good question too, right? So it's kind of up to wind farm operators and owners, right? So our ultimate goal is this technology is retrofittable, and we're going to design retrofit kits so that owners, if they want, they can purchase them and retrofit their turbines with this technology, right? So it may require some upsizing of their underground collection system and the connection to the substation, maybe kind of depends, but it's really up to the owner. But it can be deployed in a lot of areas. But I will say that it does increase, well, it's theorized too, but I'll definitely point this out, a greatly enhanced wake effect, right? So if you're familiar with wind turbines, the wake effect is the region of airspace after downstream of the wind turbine where the wind speeds are lower, and then it can interact with the higher wind speeds that didn't come in contact with the wind turbine and create these vortices and cause damage to downstream wind turbines. So the wake effect coming out of this thing is going to be a lot stronger. So if you have turbines downstream of this, they could get messed up. We don't know, it's theory, but it's likely, very likely. So that's another thing that needs to be looked at. But yeah, the wake effect of this. So if I was citing it, I would cite it like on mountains, hills, things like that, get a lot of air and there's nothing really behind it to be interfered negatively, otherwise you'd be destroying bearings and everything in the drivetrains. But it's ultimately up to the operator. If they want to upgrade all 67 of their wind turbines with this thing, I'm going to let them. They're going to buy it, I'll let them. So, yes, sir.
I was wondering about the synchronicity between the two sets of blades.
Yes.
I understand that these wind turbines have to rotate synchronously in a large farm. They will have to.
Yeah, so they're controlled, right? So they've got controllers in them that can kind of control that. This was uncontrolled, right? It's just pure air that are making the blades rotate. But in full production, things like that will be pretty tightly controlled about how we're going to do that. But that's another thing that needs to come out through testing.
But that would then involve the blades. So my question is, if the blades are synchronized, then effectively you have, what is the difference between a blade that has 3 propellers on it and a blade that has, say, 6 that are spaced at 60 degrees?
Right, so that's a good question. I get that question a lot. The difference is, this is 2 independent rotors versus 1 rotor that has 6 blades. So, because there's a theoretical maximum amount of air that you can pull out. When these blades spin, they basically make a giant circle in the air, makes a disc. There's a theoretical maximum amount of air that can be pulled out of that disc, right, called the Betz limit. So no matter how efficient your turbine is, it can never pull more than this theoretical set amount of energy. So to combat that and increase the power this thing can pull, we'll be creating another disc. So that's the difference, right? So if we just add six blades to a single rotor, it won't really change the operations of it a whole lot, right? At least, like, compared to, you'll possibly be able to get some more power, but not more than the theoretical limit. So to combat that, like I said, we're creating a second disc that can pull out even more power from that wind. Yes, we're definitely over time, but I can take a couple more.
Is it connected as a single defect, let's say, or there are like 2 electrical connections?
No, so for this, so that we can measure them, they're separate. But in practice and in production, they would be a combiner box to sum them together and output them.
So it would be like something new, actually.
Yeah.
They are both connecting to the same.
Yeah, they would be summed up and then output as a single power source. One more.
Could you explain a little bit more how you measure the overall system production capacity? Because you told that they were measured separately.
Yep. Yeah, we use Arduino. I can very happily share that information with you, not a problem. I would ask them to take that question offline and to vary over time, but I am very happy to answer those questions. That's not a problem. All right. Thank you, everyone.
I have one short question.
Yes, sir.
Did you consider the implications on the resonance of the 2 blades spinning at different speeds?
So that is another thing that we're going to look at in the next one, because this one's kind of small to see how it affects the structure and everything. So that's another item that we're going to be looking at in the future. So the good thing about the project is it gives us a lot of things to write papers about. So, but yes, no, that's a great question, because another thing is blade deflection. So when wind acts on the blades, they deflect slightly, right? So another thing is you got to make sure these things are spaced far enough apart from each other, so that when the blade deflects, it doesn't contact the other blades. And that's another thing is the effects of the rotor spacings on the power production too. That's another thing I want to look at.
The backward, the back rotor starts spinning forward too.
Oh yeah. Well, you talking about the other direction?
No, the blade, the back blade, will start to swing on the resonance.
I think we should prove that.
Yeah, I am very down with that. Yeah. Okay, thank you very much. I guess I'll take a picture by myself. here? Thanks. Thank you. Okay, next up, sorry, very over time on that. Both of evolution of proportional and nonlinear damping control schemes and an optimized power grid.
Afternoon. Just to clear something up, I'm not Twitter. He's my supervisor from Icecet. This paper was written in collaboration with Shukrinov from the Joint Institute of Nuclear Research in Russia and a supervisor. The title is Evaluation of Proportional and Nonlinear Damping Control Schemes in an Optimized Power Grid. There we go. As we move towards the future of renewable energy, more and more renewable sources need to be added to existing power grids, such as solar and wind. This, however, raises the concern of desynchronization. The more power sources we add to the grid, less likely it is to synchronize. This is when the individual sources in the grid get out of sync, and it manifests itself as blackouts. Our paper is based on a 2021 paper by Anushkin and Varisova. The aim of our study is to investigate the effects of different control methods on the synchronization of a network. In their original paper, they used a network of rotors to model a network of power sources, where each rotor represents a power source characterized by its phase. There are 10 rotors in total in the network. 9 are running at the same frequency, 1 is running at a higher frequency. Note that higher frequencies correspond to higher power outputs in the corresponding power sources. To synchronize the network, we must have the faster rotor running in sync with the other rotors in the network. Over here, we see in the original paper they used a Kuramotto-like model. This equation over here. Delta J is the phase difference between its reference signal and the JF rotor. Hj is the inertia of the JF rotor. D subscript J is the damping of the JF rotor. A subscript J is the deviation from the reference frequency, as calculated from the power output. And K subscript JL is the coupling strength between the JF and the Lth rotor. Gamma subscript JL is the phase lag between the JF and the Lth rotor. In the original paper, they applied nonlinear damping to all the rotors in the network to achieve synchronization. They used this equation over here. We have the vertical axis, that's P, is the power output of the fifth rotor. The other rotors in the network have a power output of 200, but the fifth rotor, we vary the power output. And for high power outputs, it's less likely to synchronize. The horizontal axis there, H, that's the inertia. It's the same for all the rotors in the network. The blue region here is where the network is synchronized. The dark orange there is where it is asynchronous. And the yellow is the bistable region. That's where it synchronizes sometimes, depending on initial conditions. As we increase K, and thus the damping to the rotors in the network, we see that it's more likely to become synchronized as the synchronous region grows. And that was the findings of the original paper. In our case, we investigated 2 types of proportional control schemes. The first is controlled by damping, just like in the original paper, except that we only vary the damping of the fifth rotor, and that's the faster running rotor. Rather than all the rotors in the network. Secondly, in our case, the damping is dependent on the order parameter, R over there. That's just a measure of how how synchronized the network is. So if the network is completely synchronized, that would be equal to 1. If it's asynchronous, that would be equal to 0. So what happens is that parameter there is equal to 1. So what happens is when the network is completely synchronized, no additional damping is being applied to the fifth rotor. But when it's asynchronous, the maximum amount of damping is being applied to the fifth rotor. On the right side there, we have control by a phase lag. That's the second approach. Note that it's basically the same equation as in the first. We control by damping, except we vary the phase lag between in the coupling between the fifth rotor and the rest of the rotors in the network. To achieve the former, control by damping, we need to add resistance to the power lines in a power grid. This doesn't, however, have dissipative effects in the power network. In the latter case, we just add, we vary the capacitance in the transmission lines. Here we have the regions of synchronization or proportional control by damping. It's the damping to the fifth rotor, and we see that as we increase the damping, eta in this case, the synchronous region grows, and in this case it's only applied to the fifth rotor. So even in this case, we see that the network, it aids in the synchronization of the network. We see that asynchronous region shrinks and the synchronous region grows. Here we are not looking at directly whether it synchronizes or not. We are looking at the phases of the rotor. So here we have a key. It's the phase 1, 2 pi. When it's white, it means it's leading the reference signal by pi, and when it's black, it means it's lagging behind by pi. The columns here are the rotors. Each column represents a rotor, and you can see the fifth column there. That's a faster running rotor. It's running faster than the other rotors in the network, and you can see it's not synchronized. Whereas when we increase the damping of the fifth rotor, we see it does synchronize, since it forms these bars of uniform color, indicating that they are in sync. Here we have a similar scenario, except that we initially eta is set to 0. That's the damping of the fifth rotor, the additional damping. It is set to 0. And then at time equals 5, we increase eta to a higher value. On the left side, we increase it to 2. On the right side, we increase it to 3. We see that if we look on the left side, despite the damping coefficient being increased to eta equals 2, which is larger than the eta equals 1 that facilitated synchronization in the previous slide, the network does not synchronize. This can be explained by the fact that the other rotors in the network synchronize while t is smaller than 5, thereby increasing the order parameter r, and the higher the order parameter, the weaker the damping. Thus, in this case, eta equals 2 is insufficient to facilitate synchronization. But if we look on the right side, when we increase it to eta equals 3, then it does synchronize. Here we have the time evolution of the order parameter. We again have the case where eta is increased to 3 and increased to 2. Initially, eta equals 0, and we see the order parameter as the measure of how synchronized the network is. It oscillates up and down, and then when we get to t equals 5, we see that in the case of eta equals 3, it settles as 1, the order parameter, so that means the network is synchronized. In the case of eta equals 2, there's a continuation of the oscillation of the order parameter, and the network does not synchronize. On the right side, we see a figure of the average frequencies of the rotors in the network between time is 24 and 32. That's well after the value of eta has been increased. So we see the fifth rotor there, the red squares indicate the case where eta equals 2. We see the fifth rotor running faster than the other rotors in the network. That's just not synchronized, and in the case of the blue triangles, that's eta equals 3, the network does synchronize. Here we have a comparison between the non-linear damping and the applied non-linear damping applied to all the rotors and only to the fifth rotor in the network. So, as I showed you in the previous slide, this is the original paper results where they applied this damping to the all the rotors in the network. And what we did is, on the left side here, we tested the same scenario, except that we applied damping only to the fifth rotor. And unlike the previous case where it was dependent on the order parameter, in this case we were using the same formula. So it's just applied to the fifth rotor, that's the fastest one rotor. And we find similar results, except that we use much less damping to achieve the same results. So for instance, here we have 0.05, the K value of 0.05, that's the damping. And that would give us a similar result if we just apply to the fifth rotor as we did in the original paper when it's applied to all the rotors in the network. But then the K value is 5, not 0.055. So for 1% of the K value, damping, only applied to the fifth rotor in the network rather than all the rotors, you get a similar effect. And this would be much less dissipation in the network in general. Here we have regions of synchronization for proportional control phase lag. This is where we vary the phase lag in it, between the fifth rotor and the rest of the rotors in the network. And as we increase phase lag, we see the network is more likely to synchronize. But interestingly enough, we also see a growth in the asynchronous region as we increase the data here. So the phase lag has a very funny way of making it asynchronous in certain cases as well. And we see that this continues up to 2.4, where you don't want to increase the phase lag much more beyond that necessarily, because the asynchronous region actually expands into the synchronous region, and especially for values, low values when they have high values of power output on the fifth rotor. And that is the end of my talk. Thank you for your time. Are there any questions? There are some references if you're interested.
Good job. Any questions? All right. Yeah. Okay, our last presenter, Kamlash, design and implementation of a photovoltaic energy storage system.
It is such an honor to stand and present in front of you. It's morning, or no, afternoon, sorry. So I'd like to begin by asking this question to all of you. What actions are you taking to support the sustainable goals development, sustainable development goals? You do not have to answer that now, you can answer that later. Okay, so I will start sharing my presentation now. Just a few seconds. Okay, so good morning, ladies and gentlemen. I'm standing before you to present about the design and implementation of a photovoltaic energy storage system. My name is Lizwelula Makabashe, and I'm an undergrad student at the University of South Africa, also known as UNISA. So for the agenda of this presentation, I will be doing the introduction, and after the introduction, I'll do the methodology. You will see the results in the discussion, and you will also see or get to hear about the future research as well as the conclusion. Now, if we go to the introduction, I am well aware that we all know that Africa is believed to be the hottest continent in the world, and yet, if you look deeply at that, the access to electricity is still the lowest. Maybe we can ask ourselves, what are we really doing with this excess heat that we have? Because in 2022, a research by the CSIR showed power cutoffs of about 2,276 gigawatts hour. And that was only for the first 6 months of the year. And it was about 90% higher than what was shown in 2021. This has crippled the economy, it has led to fatality, and hence the use of renewable energy today. If you look at solar, solar capabilities are massive, with about 220 watts per square meters solar radiance in the Southern Africa region, compared to 100 watts per square meters in the region of Europe. Also, if you look at solar power, we know that it is intermittent, and when you couple it with a battery energy storage system, also known as BESS, that will complete the picture, and it will also minimize the effect of the dark curve. So now, the solution to this problem that I've spoken about now is based on a design and implementation of photovoltaic energy storage system using lithium-ion batteries. Now, if you look at the methodology, I'll just go briefly through the specifications of the components that are used in this project. So, for solar, we have power maximum of 250 watts with 60 cells per module and 8 modules per string, as well as voltage at maximum power being 30.7 and the current at maximum power being 8.15. And if you look at this, the 250 watts that we have, it comes from the formula P is equal to VI, which is this current that we have of 8.15, as well as the voltage of 30.7. And then the battery specifications, the type that I'm going to use is the lithium ion, and the nominal voltage is 240 volts at a rated capacity of 48 AH, as well as the initial state of charge of 95%. And then the grid specifications, we have 3 phase with 325 peak voltage as well as 50 Hz frequency. So now, the implementation of this study was done using MATLAB, because if you think about it, in any kind of project that you want to work on, you would not want to create or only see mistakes when you're in the field. But to avoid that, it's better to first do a simulation, and then so that if there are any mistakes or any problems that you're going to face, then you try and solve those problems early in time. So that's why I'm using MATLAB simulate. So the figure that you see, figure 1 on the right side, it basically, the logic behind it is that the grid here, it will basically feed the load as well as the batteries, that is by charging them. And the solar panels that you see here, they will feed the load and they will also charge the batteries. So that is what you see there on that figure. So this is the design on MATLAB. If you look at it, it is basically on the right side where I have the dotted lines, we have our bus bar there, and then at the top there we've got our solar, and then we've got our battery system as well as the grid source. And then to continue, we will look at the results and the discussion. So now, with my simulations, what you'll see in the following slides is a simulation of PV, which will show voltage, current, and power. And on the battery simulation, you will see voltage and current. And the simulation for the SOC, you will see it will run from 85%. And in the inverter and grid simulation, you will see voltage and current. So I will just play this short video so that you can have an idea of what will happen when you do a simulation. So the idea is that if there is sun outside, you know that you will be able to generate electricity. So the maximum that you'll be able to generate is about 2,000 watts. And then when that happens, we know that when the battery is charging, then the SOC increases. As the SOC increases and the batteries are charging, the voltage also increases until it reaches a steady level. And when the charging is also taking place, what you need to also take note is that the current it goes to minimum. And then on this side, you see that there is fluctuations for the inverter grid, which are shown to be constant. So that's what basically happens. And then now I will continue to show you. So for this simulation, it was based on lithium-ion battery. So now I will try to show you the results for other battery types. So this is what you just saw for the lithium-ion, and then this is what will happen for the lead acid. If you notice something here, I've mentioned that when the batteries are charging, the voltage will increase until it is steady. So what you see here is that there is unsteadiness that you can note on the voltage. And then if you look at a different battery type, which is NICD, another characteristic of lithium-ion is that it charges quickly compared to other batteries. So what that means is that it will reach this level. Okay, when it's at 3 here, for lithium-ion battery, this level of SOC, it will be higher than what you can see here. Let me just go back a bit so that you can see that. So, if you can notice here, we have here 95.001, and it has exceeded, at 3, it has exceeded that number. But if you look at other batteries, and this, to be specific, the one that I have noted here, the NICD, when it is reaching that 3, it is still less than 95.001. And then if you look at another battery that I've used, it's a nickel metal hydride. So it's the same condition that we saw on the previous ones, which are not lithium-ion. So there is a variety of batteries that differ in property, as you saw, and the cost as well is what makes them fit for each specific purpose. So does it make sense for you to spend less upfront for lead acid batteries or any other battery type, or invest in the efficiency and longevity of lithium-ion batteries? I want you to think of that as well. If you look at lithium-ion batteries, they are by far the best in the path to a sustainable world for all of us. And this technology is also characterized by its high efficiency, high energy density, long lifespan. It has low maintenance, as well as it is environmentally friendly. Now, if you look at the future research and conclusion, the lithium-ion battery storage has been proposed to combat the challenges faced by the intermittent renewable energy use. Solar is not new. It's a subject that we have been hearing about. But if you look deeper at this, all studies, they really compare on a sharp future decrease in battery investment, which means that even though it has been there out in the market, it has been growing, many people have been facing challenges of cost. So with what I'm talking about here, I'm trying to say that even though it's been there, and many people maybe back in the days, or even now, are struggling with the cost of it. Here's an example of June Solars. They have showed a decrease of about 20.6 price decline, and that was in 2023. So what I'm trying to say is the cost of the system is going down, which will offer a reliable and cost-saving solutions to our households and businesses. And we know with everything that we are doing, we do not only think about today, but we also have to think about what will happen tomorrow. So future research could also investigate how artificial intelligence can be used in energy storage, and this not only advances the use of renewable energy, but it also puts the country in good statistics of decarbonization, which is what we see in now. I welcome your questions.
All right. Any questions? Yeah, I have one, I guess, question slash comment. Did you do a cost analysis between the different battery types? Because yeah, lithium performs the best, but you should break it down to like the cost per megawatt or cost per watt for the batteries. Because it's a good, yeah, it's a great battery, but if it costs a lot, it's probably not a good financial decision. But no, I definitely agree with you. So it was good overall. I would recommend making cost analysis.
Thank you. I will look into that in the future.
All right, guys. Good job. All right, this concludes our session. I believe there's a coffee break coming up, so thank all of you for coming and great job in your presentations.
Everybody is so the photos you can gather outside the front of the hotel. Then you go to move to a spot which is got kettle lamps in the background.
Oh, we're taking a group photo, right, for the conference? Yes. All right.
Outside the hotel.
Now,